Okay, let's take a look at question 1. So here we have a diagram. There is a straight line path OZ. Distance from point O to A is 10 meters. Trees are planted along the straight path from point A to Z inclusive of both points. 6 trees are planted in total, with each tree measuring 30 meters apart from each other. Find the length of OZ. So this is a rather simple question. It's just a warm-up. So how do you find the distance from O to Z? You can just take 10 plus 30 plus 30 plus 30 plus 30 plus 30. But that is a bit slow. So you would like to rewrite it as 30 times how many? 5. But how do you get 5 when you have 6 trees that are evenly separated, including point A and Z? It's really just 30 times 6 minus 1, right? So in general, I'm trying to bring up the formula for the arithmetic sequence or progression. You have a un, it will always be equal to a plus bracket n minus 1 times d. Oh, you start with the initial distance a, and then you jump plus 30, plus 30, plus 30, plus 30, plus 30. But how many times is that? It's 30 times n minus 1, in this case 6 minus 1. Okay, this is the formula of arithmetic sequence. The nth term, the 6th term. Okay, you can also maybe denote this as U6. Next, question 2. A car has 6 forward gears. The fastest speed of the car in first gear is 28 km per hour. In sixth gear, it's 115 km per hour. Given that the fastest speed of the car in successive gears is modeled by an arithmetic sequence, so that means the formula is un equals to a plus bracket n minus 1 times d. Find the fastest speed of the car in third gear. So what we know that n equals to 1 means that u1 is equals to 28. But that's really just equals to a, right? If you substitute n with 1, get 1 minus 1, here becomes a 0. 0 times d will give you 0. And a plus 0 is just a. So that's why this is just equal to a. So we found out 28 is equal to a. How about if n is equal to 6? We know that u6 will be equals to 115. But u6 is the same as saying you use the formula, but you replace the n with 6. What else can we replace in this formula? We found out a is 28. So we can replace the a there with 28. From there, we can solve for d. So what is d? It's just 115 minus away 28 divided by 6 minus 1 equals to 17.4. Okay, that's the common difference. So that means that you start with 28, right? That's 0. Start with 28, and then you add on 17.4. Add on 17.4. Add on 17.4 as you go from the first gear to the second gear to the third gear and so on. Okay, so now the question asks us, what is the fastest speed of the third gear? So third gear means n equals to 3. We just need to find out what's u3. Using the formula, it's a, which is 28, plus n minus 1 times d. In this case, d is 17.4. But what's n? N is 3. So use the formula and you get 28 plus bracket 3 minus 1 times 17.4, which will give you 62.8. Okay, km per hour. That's your answer for part A. How about part B? Let's take a look. Given that the fastest speed of the car in successive gears is modeled, now this time they change to a geometric sequence. Find the fastest speed of the car in fifth gear. So geometric sequence just means instead of plus, 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 we times, times, times. Instead of adding a constant difference of d, each time you add, we change it to times. Times something, times something, times something, and it has to be the same number. So we restart the question, pretend that part A didn't exist, and we deal with this part here. So let's see. First gear is 28. Oh, wait, sorry. The general term I should mention is, let's say Tn. To make it different from U, I use the letter T. It will be equals to first term multiplied by R to the power of n minus 1, where R is the common ratio, A is the first term, n is the number of terms. Okay, so that means that I can make use of the information given. We mentioned that first gear is 28, sixth gear is 115. So you do the same procedure, but this time with Tn. So T1 equals to A times R power 1 minus 1, which is 0. So R power 0 is 1. So this is just equal to A, which is equal to 28. Okay, so we get A equals 28. How about T6, sixth gear? You just have to take A R power 6 minus 1, 5, which is equal to 115. But wait, we also know what's A, so we can immediately replace the A over there with a 28. So 28 times R power 5 equals 115. Can we solve for R? Yes. Divide by 28 first, then you take the fifth root. Let's see what that is. 115 over 28. Then you take the fifth root. It's approximately equal to 1.3265 ISF. In this case, what else did they ask us? They asked us to find the faster speed of the car in fifth gear. Okay, so fifth gear means what? Means you want T5, which is really just A, 28, multiplied by R to the power of 5 minus 1. Yeah, then we'll just have to use the approximated value for R, 1.3265 to the power of 4. Okay, type that in the calculator. We will get approximately 86.694, which is approximately 86.7 km per hour, 3SF. Okay, next question. Go. First, second, and fifth terms of an arithmetic progression. Let's just write down AP colon like this, and then we write down UN to represent the nth term of the arithmetic progression. Formula will be A plus N minus 1 times D. In this case, U1, oh, sorry, maybe I should also write down geometric progression here. Tn, I'll use Tn to represent it. It will be A times R power N minus 1. What do we know about the AP and the GP? In the arithmetic progression, the first, second, and fifth, so U1, U2, and U5 are equivalent to the first three terms of the geometric progression. So T1, T2, and T3. They are equal to each other, like this. But what is U1? If you use the formula, it's just A. It's just A plus D and A plus 4D. Oh, just use the formula. Sub in N equals to 1, 2, and 5. How about T1, T2, and T3? You just sub in the formula with 1, 2, and 3 respectively. You get A times R power. Sorry, correction. Here it shouldn't be a A. We don't know this for sure. So we should use a different letter, let's say P. The constant may not be related. I cannot recycle the same letter. So let's just call it P times R power 0, which is just 1. So it's times R power 0, which is just 1. So P times 1, which is just a P. You can drop the rest. And how about T2? Substitute the N with 2, you get P times R. Substitute N with 3, then you realize it's PR squared. What's the pattern here? Times R, because it's a geometric progression, times the same common ratio R. P goes to PR times R, PR goes to PR squared times R. So this, and this are equal. That is very useful to us. In particular, this part here, we can make use of it. Since we know that geometric progression, they have a common ratio, that really just means that T2 over T1 is equal to R. But what about T3 over T2? It's also equals to R, which means that they are both equals to R. Maybe I'll present it this way. I'll put the R on the left-hand side here. And T2 over T1 equals to T3 over T2. But would it be useful if we just directly substitute in with PR and P? Not really. We will get PR over P equals to T3 over T2. If you directly substitute with the PR square and PR, what happens? P and P cancel off, you're left with R on the left. P and P cancel off. R and R cancel off, you're left with R on the right. You get R equals to R, which is not so useful. True, but not so useful. What we should do instead is to make use of the new information, which is that T1 is actually equals to U1, and U1 is equal to A. So that means we can replace our T1 over here with a A. So T2 over T1 will be something over A. Oh, likewise for T2, we know it's equal to U2, which is A plus D. So we can just sub in with A plus D on the numerator. How about T3? T3 is PR square, but we don't use PR square. Instead, we use the fact that it's equal to U5, which is then A plus 4D. Why is it equal to U5? It's because it was given by the question. First three terms. First three terms, they are. R means they are the same. Okay, so T3 is actually A plus 4D. You can replace the numerator with A plus 4D. Divide by T2, it's again A plus D. T2 is A plus D. Okay, good. So is there any other information that we have yet to use from the question? Yes, this part here. Third term of the AP is 5. So that really means that third term of the AP, we haven't found out what's that. So U3 equals to A plus. In this case, third term, so it's 2D. We know that this is equals to 5. So let me think a bit. Okay, yeah, we haven't used this information here. U3, which is A plus 2D equals to 5. It's an equation involving A and D, two variables. So probably we need to involve simultaneous equations. We need to get another equation involving A and D, which is actually over here, right here. So we need to solve them simultaneously, and we'll have to get the values of A and D. Okay, carrying on with the algebra here, I don't want to do any substitution yet. I want to simplify this guy here instead. So let's try to do that. Simplify this. What do we get? Cross multiply. You get A plus D times A plus D, which is A plus D bracket square. Multiply the A over, and you get A times A plus 4D. Expand. You get A square plus 2AD plus D square. Expand. You get A square plus 4D. Anything to cancel? Yes, A square cancels off. You're left with 2AD plus D square equals to 4D. But wait, 2AD, sorry, I forgot to multiply in the A. So 2AD plus D squared equals to 4AD. Anything else to cancel? Yes, 2AD and 4AD. So simplify and we get D squared equals to 2AD. At this stage, you see D squared, you see D. Maybe you are thinking of dividing by D on both sides, but that's not such a good idea because you will lose one of the solutions. Instead, you should bring over to the other side. So D squared minus 2AD equals 0. Factor out D, you get D minus 2A times D with brackets. So now that you have two factors multiplied together give you 0, it means the first guy equals 0 or the second guy equals 0. Bring the 2A over, you get D equals to 2A. So now you have two separate cases, D equals 0 or D equals 2A. That's when I will move over to the right side and I'll say case 1, D equals 0. Draw a line. Case 2, D equals to 2A. D equals to 2A. And we will try to solve each case separately. So when D is equal to 0, let's just deal with that case. We also recall that there was the formula over here, A plus 2D equals to 5. So we can maybe write this down over here, A plus 2D equals to 5, and therefore A will be equals to 5 minus 2D. I'll call this equation 1. Then in the case when D is equal to 0, we'll have to sub D equals to 0 into equation 1. What will we get? A equals 5 minus 2 times 0, which is 5. Now, why do I want to find 5? Because we have to answer the question. What did the question ask for? It asked for the fourth term of the geometric progression, which means we want to find T4. So what's T4? It's P times R power 3. But wait, what's P? Oh, P over here. It's actually equal to A. So that means we can replace this P over here with A. So it's really just A times R power 3. So what are the two ingredients we need to solve the question to find T4? We need to find out what is A. We need to find out what is R. Okay, so we already did that. We found out A is 5. What else do we need? Now we need the R. So what's R equals to? Oh, right over here. R is equals to T2 over T1 or T3 over T2, right? The ratio of the geometric progression. So that means I can just use the formula R equals to T2 over T1. In this case, don't use the PR over P. The P will cancel off. You're left with an R again. That's not useful. Instead, use the A plus D and the A. Because T2 is actually U2, which is A plus D. T2 is actually U1, which is A. So now this simply becomes A plus D over A. wait a minute. We also know what is D. We also know what is A. A is 5. So we can, D is 0 and A is 5 in this particular case. So that means we'll have 5 plus 0 over 5, which means we'll get a 1 for our R. Are we done? No, we need to substitute into the formula for T4 over here, AR power 3. So T4 is actually equals to A times R power 3, or you can just directly substitute in A is 5 times 1 power 3, which is 5. T4 is done for the first case where D equals to 0. Now we move on to the case 2, D equals to 2A. In this case, I'll do the same procedure as the left-hand side. I'm just going to replace D with 2A. So substitute D equals to A into equation 1. We get A equals to 5 minus 2D, but the D is 2A. No? So you get 5 minus 4A. A on the left. Bring the 4A over, you get 5A equals to 5. Therefore, you get A equals to 1 by dividing by 5. Are we done? No. Now we have A. What else do we need? We also need R. Remember the formula for T4? It's still AR cube. It's still AR cube. But it's just a different value of A, different value of R. We found our A. Now it's time to find R. How to find R? Recall, R is exactly the same as the working as before. R is actually equals to T2 over T1, which is A plus D over A. But in this case, the A is a 1, the D is a 2A over A. But wait a minute, A is 1, so it's really just 2 times 1. And the A at the bottom also can be replaced with a 1. Simplify, you get 1 plus 2 over 1, which is just a 3. Are we done? No, we still need to find T4. So T4 is now equals to A times R power 3. So it's 1 times 3 power 3, which is 27. That's how we get our answer for the two values of T4. Okay, now let's take a look at question 4. For part 1, we want to find out the sum to infinity of 20 times half power R. So let's just copy that down first. 20 times half power R. And also take note that there's a R equals to 4 to infinity. So the first term is not as simple as substituting the R with a 1. Okay, so let's figure out what this really means. This is really just taking the limit as n goes to infinity of a summation from R equals to 4 to n of 20 times half power R. Actually, maybe we can, that's fine. But now that you have a factor in front, what can you do with it? You can actually factor out of the summation. So it becomes the limit as n goes to infinity of 20 times some half power R as R goes from 4 to n. Then this 20 can be factored out further. We get 20 times the limit as n goes to infinity of summation R equal to 4 to n of half power R. Now this guy here is a geometric series, right? Because if you sub in R equal to 4, you get half power 4. Then you have to sum with half power 5, then half power 6, and so on and so forth until infinity. This common ratio is half. So the formula for a geometric series is what? It's A times 1 minus R power n, all divided by 1 minus R. A is your first term, R is your common ratio, n is your number of terms. Now, just to take note, this is actually going to be a geometric series, but you're gonna take the limit as n goes to infinity, which really means that it upgrades itself into S infinity. You take the limit of this series as n goes to infinity, which means that what you'll be left with is actually just the limit as n goes to infinity of Sn, right? You're just sort of replacing the n with infinity, but it's more like taking the limit. But Sn is what? Sn is actually A times 1 minus R power n, all divided by 1 minus R. Now take note that the only thing affected by n is this guy, R power n. This A over 1 minus R is just a number divided by 1 minus another number. So overall, it's still just a number, a constant. And whenever you have a constant, you can actually factor it out. So you'll be left with A over 1 minus R multiplied by limit as n goes to infinity of R power n, 1 minus R power n, Yeah, that's all. Okay, good. Then with brackets like this. Continue simplifying this, we end up with a limit of 1 minus r power n. So limit, or as n goes to infinity to 1, it doesn't affect the 1, so leave it alone. Then you subtract away the limit as n goes to infinity of r power n. Now, here we will assume that the modulus of r is less than 1, i.e. -1 less than r less than 1. In this case, as you take the limit, it will just go towards 0, right? As n goes to infinity. Imagine if r is equal to, let's say, half. What's half power infinity? Well, writing this down is not very accurate, but you can think of it as half to the power of a very big number, let's say 100 or 1,000 or 10,000. You'll see that as you start to, what do you call it? As you start to increase the power, the value of this half power something just drops towards 0. Not exactly equal to 0, it's always slightly above, but very, very close to 0. But when you go towards infinity, the limit, it just becomes 0. So it means that it's a over 1 minus r multiplied by 1 minus 0. What's 1 minus 0? It's just 1. 1 times a over 1 minus r is a over 1 minus r. That's how you get the formula for S infinity. So the infinite geometric series S infinity will just be a over 1 minus r, the sum, the infinite sum. So that means we can now use this formula, but you have to take note what is a. A is first term. So be careful here. Your summation starts from r equals to 4. So your first term is actually what? Half to the power of, not 1, but 4, which is some number. It doesn't matter, we'll just leave it as half power 4. Then divide by 1 minus the r, where r is the common ratio. What's the common ratio? It's just half. Remember this pattern here? The common ratio is at the bottom, times half, times half, times half. So r equal half. So use the formula now. We have a 20 in front, not forgetting. The 20 in front, you have to multiply by a over 1 minus r. But replace the a, replace the r with half power 4 and half. This entire thing can be keyed into a calculator. Just do a little bit of exponential calculation, exponential rules, and you will simplify this down into something not so important to figure out what it is, but the final answer will become 5 over 2. Let's try to calculate this manually without a calculator, but just take note, for exam purposes, just use a calculator, get this answer and move on. Now I'll show you how to calculate this guy manually. So half power 4, not important, not required for exam. Just use calculator, speed things up. Half power 4 divided by 1 minus half, what is that equal to? Denominator can simplify as just 1/2. But there's a half power 4. So maybe we can do this. We can treat this as bracket power 1. Then power 4 over power 1, same base. What happens to your power? You subtract the power. So it becomes half to the power of 4 minus 1, which is half power bracket 3, which is actually 1 over 2, 1 cube over 2 cube, which is 1 over 8. Then 20, you multiply it by that guy, 1 over 8, you just simplify to 5 over 2. Yeah, that's for part 1. Let's move on to part 2 now. Now you want to show this formula is true. So it's a proving question. You want to show that this is true. Also, you don't try to calculate. You just start from the left-hand side and you slowly work your way towards the right-hand side. I think that would be quite okay to do. Or alternatively, you can start from the left-hand side, you reach somewhere in the middle and you get stuck. Or and then you manipulate from 2 and you work towards the middle as well. So you just meet in the middle and you show that they are both equal to that middle expression, then you would have shown that they are equal to each other. But I think working directly from left to right is probably the best way to go because the left-hand side is complicated. Not complex number, just looks quite complicated, but the 2 is very simple. 2, we can't really do anything, but the complicated one, we can do something. So we work from the left, the complicated, towards the easy side. So we'll work from the left towards the right. So let's start with LHS being the summation of this logarithm, base 5, n plus 2 over n plus 1, from n equal to 1 to 48. So just copy down the n equals to 1 to 48 a few times. But here, the most important part is to realize that every time you take a logarithm of a fraction, you can actually split it up into a difference, right? Log of n plus 2 minus away log of n plus 1. with the same base. So every time you have a difference and you take a summation, you must know that this is an idea known as the method of difference, or what we call the telescoping sum. Why telescope? Because a telescope, you can think of it as like this. It can extend to become long, but you can also collapse it down. Right? You can shrink it all down and collapse it into just a tiny little cuboid looking thing. Okay, but anyways, let's just do the math. So substituting the n equals to 1 to 48, you should do, the way to do method of difference is to substitute in first few terms, and you start to see the pattern where many of the terms start to cancel off because of the minus sign over here. Positive and negative same terms, they will cancel each other off. Okay, so basically, if you just sub in n equals to 1, this red color n equal to 1, it don't have to be written. You can just think of it in your head. I'm just writing it down to be clear. Substitute n equals to 1, then you get log base 5 of 1 plus 2, which is 3, minus away log base 5 of n plus 1. In this case, it's 1 plus 1, which is 2. And it's a summation, so we plus the next term. Increment n by 1. So n is now equal to 2, sub in n equal to 2. So we get log base 5 of 2 plus 2, which is 4, minus away log base 5 of 2 plus 1, which is 3. The pattern here is as n increases, the value inside the bracket increase by 1. Let's just do one more. N equals to 3. Then we'll just get the exact same thing, but you change the number 4,3 into 5,4. Continuing on plus dot dot dot, you can go on to the last 3 terms. So n equals to what do we want of? We end with 48, right? So let's just continue until 46, 47, and then finally 48, and see what those values are. So if n equals 46, we'll get what? Log of 46 plus 2, which is 48, base 5, minus away log of 47, base 5. Next one is plus log of 49, base 5, minus away log of 48, base 5. Plus log of 50 base 5 minus away log of 49 base 5. Okay, good. So now we start to see a pattern. The positive log 3 and negative log 3, they cancel each other off. Likewise with the log 4, the log 5, there's a hidden negative log 5 base 5. It's just not written. It's in n equals to 4. I didn't write it down. You shouldn't write it down because there's no time to write it down. Too many terms. Just know that this will get cancelled off. Likewise for the log 47 base 5 with a negative, there should be a positive version when n is equal to 45 that will just cancel away. So cancel away dot dot dot. And what else? Log 48 and minus log 48, log 49 and minus log 49. What am I left with? Top half, bottom half, top cheese and bottom cheese. It looks like a Swiss cheese with a lot of holes in the middle because they cancel each other off. A lot of holes in the middle. Like a bag of chips inside got a lot of air. There's only the top half and the bottom half left behind. So simplifying this down, what do we get? We'll just get log positive, the positive guy is log 50 base 5. The negative guy is minus log 2 base 5. You don't need to put the bracket. It's fine. Okay, I'll just remove the bracket. Then in this case, since they are both logs and you subtract and you have the same base, you can just use a logarithm rule. The difference becomes a quotient. Minus become divide. So 50 divided by 2 is 25. So you get log 25 base 5. But 25 is what? 25 is 5 squared. So this is log 5 squared base 5. You can use a bit of power rule, bring it down. This is not differentiation, just bring it down. So 2 times log 5 base 5. Please don't go and minus 1 or something. It's a coincidence if it works. This is logarithm. Just bring the power down. So 2 times log 5 base 5, this is actually equal to 1. Then 2 times 1 is just 2. Another way to do this would be to see x equals to log 25 base 5. What's the exact value? By definition, you can bring the 5 over. So you get 5 power x equals to no more log, just 25. Just 25. But 25 is 5 squared. So 5 power x equals 5 squared. Comparing the power, because the base is both 5, you can just compare the power to conclude x equals to 2. Done. All right. That's for part 2. Okay, let's take a look at question 5. Our sequence is such that u1 equals to p is some constant, and un plus 1 equals to 2 times un minus 5 for n more than 0. Okay, so this is a type of sequence that's known as a recurrence relation. Technically, it is no longer in the syllabus, but it came up in 2020. This is 2020. So they still expect you to be able to handle it, not by solving for un directly, but in a more straightforward way. You can use this formula here, involving a sequence in which is a function of n. So part 1, part A, describe how the sequence behaves when p is equal to 7. So let's just copy down the formula first. Un plus 1 equals 2 times un minus 5. N more than 0, u1 equals to p. And for part 1, part A, question 5. Part A, it says p equals to 7. Okay. So what we can do is to check u, just sub in the p with 7 first. So u1 equals to p, which is 7. Then how about u2? Using the formula, it's 2 times, how do you read this formula? It means that the current n plus 1 term is equals to 2 times of the previous term. Previous because n plus 1 go to n, you're just subtracting 1. And then you subtract away 5. So that just means 2 times of the previous term, which is u1, subtract away 5. If you are faster, you can immediately see that u1 is the 7. So you can replace the u1 with a 7. Then 2 times 7 is 14. 14 minus 5 is a 9. Next, how about u3? Same thing again, just 2 times the previous term, u2, which is a 9, minus 5. 2 times 9 is 18. 18 minus 5 is 13. So what you start to realize is that there's a pattern. 7 go to 9, you plus 2. 9 go to 13, you plus 4. Next one will be plus 6. Let's just check whether it's true or not. So u4 will be equals to 2 times of the previous term, which is 13, minus away 5. 2 times 13, 26, minus 5, 21. Oh, that's not true. Maybe it's not true. We don't really know that it's plus 6. Let's see what this is. 2 times 13. Did I calculate wrongly? 26 minus 5, 21, plus 8. Oh, it's not such a simple pattern, plus 2, plus 4, plus 6. It's actually plus 2, then plus 4, then plus 8. So what's the pattern? The pattern is something, but it is not important. The difference, the pattern in the difference is not that important. The more important point to take note is what is the behavior, because that's what they are really asking you. Eventually, as you go on to bigger and bigger indexes, U100, U1000, U1 million, what happens? You realize that you're just adding and adding and adding, and you're adding bigger and bigger numbers. So that just means that eventually this sequence diverges to, or shouldn't, sorry, I shouldn't say diverges. This is not a sum. This is just a sequence, right? Sequence will tend towards in positive infinity. So don't need to say positive, just say infinity. It's implied to be positive. Oh, how else can you calculate this with without using manual calculation? You can actually use a GC. Let me show you how to do it. Okay, so we already know that u1 equals to p, which is equal to 7. So that means, and this is un plus 1 equal to 2 times un minus 5. This is what is known as a recurrence relation, a special kind of sequence. And you can actually determine its behavior using the GC. They can calculate all the terms for you. Here's how you do it. You go to mode. Then under mode, there's function parametric polar sequential. SEQ means sequential. Select that, enter. Then you press, you can quit or you just directly go to y equals. You reach this page. N min, un, u bracket n min. What does it mean? Then after that, you got vn, vn min, wn, wn min. You can ignore the v and w, they're just separate terms. It's just like a y1, y2, and y3. But we focus on the un. Here, n min equals to 1. means what's the smallest minimum value of n. In this case, we have n more than 0, and n should be a whole number, so n equals to 1. So by default, it's already set to 1, so it makes sense. We don't need to change the n min. How about un? We know un plus 1 equals to 2 times un minus 5. But on the calculator, unfortunately, they start with un. So that means your index number actually needs to subtract by 1. So what do I mean? What I mean is un plus 1 is equals to 2 times un minus 5. But you now need to rewrite it as un equals to 2 times of un minus 1 minus 5. Basically, the index has to decrease by 1 so that on the left side here, it's an n. So this is what this right-hand side is what we will be keying into the calculator. 2 times u of subscript n minus 1 minus 5. But we can't write our subscript. So here's how we actually do it. Back to the calculator. So yeah, 2 times u n minus 1 minus 5. How to do it? Just press a 2 first. Then after that, go to second number 7. Do you see a blue color letter U above the 7? Yeah, that's the U. Small letter U. I'll make sure you don't pick the big letter U. Must be small letter. Then you open bracket n minus 1. So variable minus 1. Notice that the variable, when you press it, it's an n. You see x, t, theta, and n. We are in sequential mode, the fourth one. That's why we are using the letter n. Now un minus 1, and then subtract away 5. Now how about un min? So it means u, in this case, n min is equal to 1. So un min is u1, u bracket 1, the first term, which we know u1 equals to p, right? So p is equal to 7. So we key in a 7 here. Then we can draw a graph and we can, can't see anything. Maybe need to zoom out a bit. Zoom out. Need to zoom out a bit more. Number 3, zoom out. Let me start to see the graph. Can you see a bunch of points? It's going, it's increasing very fast, so we can't really see much. We can also change the Y scale, so we don't need we don't need negative. So we just show a larger value of Y. Let's say we go to 50. Okay, maybe even bigger. Let's say we go to 1000. Draw the graph again. You see, it just increases very, very quickly. But this is actually not that useful to you. You should actually just press second table. Then they'll calculate all the values for you. For different value of n, you get different value of un. They'll do the manual calculation for you. And you start to see the 7, 9, 13, 21, which is what we actually calculated manually. So from here, I hope you can realize that the number just keeps increasing, which means that the sequence actually goes up to infinity. You just keep on increasing and increasing. 2.1 times e power 6. E6 means times 10 to the power of 6. So on and so forth. Basically, it just keeps increasing. Yeah, keep increasing. So that is part 1, part A. Now let's move on to part 1, part B. If we change the p value to now 5, we just have to use the same formula again, but we replace the p with a 5. Let's see what we will get. You'll end up with u1 equals to p, which is 5, u2 equals to 2 times of the previous guy, which is 5, minus away 5. We end up with a 5. How about u3? u3 will be 2 times of the previous u2, which is a 5 again, minus away 5, which goes back to a 5. Repeat, u4 is 2 times 5 again. Because this 5 this time is u3. Previously, this was u2, and that one was u1. Okay, I don't write that down, very messy. Then you subtract 5, and then you get back to 5 again. It keeps on repeating. So eventually you realize that as you keep on increasing the value of n, it just keeps on repeating the 5. So you can just describe the sequence as sequence stays constant at 5. Constant. U1, U2, U3, 5, 5, 5, 5. It just stays at 5 all the time. Next, we move on to part B, question 5, part B. Another sequence is defined by V1 equals A, V2 equals B, where A and B are constants. And Vn plus 2 equals to Vn plus 2 times Vn plus 1 minus 7 for n more than 0. For this sequence, V4 equals to 2 times V3. So don't be scared of all the n plus 2, n, and n plus 1. You just need to know that current term is n plus 2, and you're looking at the previous term as well as the previous term. Just follow the subscript and you won't go wrong. The question here is actually just testing you on whether you understand how to follow a sequence formula and substituting what we call the initial conditions, V1 and V2. Then from there, you can form two simultaneous equations using this pattern here, V4 equals 2 V3. Then from there, you can solve for B and solve for A. So let's begin. You don't need to solve for Vn explicitly. Vn as a function in terms of purely in terms of n. It's actually quite difficult. It's in further math. Purely in terms of n is not needed. And it will be a waste of time here. So let's just deal with this question. How? What we know is that there's a V1, which is A, and there's a V2, which is B. So can we find out what's V3? Yes, we just need to use the formula here. What is V3? V3 is, you treat this as your n plus 2. So Vn plus 2 equals to Vn plus 2 copies of Vn plus 1 minus 7. If n plus 2, we know it's 3, that means that n equals to 1. So we can use n equal to 1, sub in here, sub in there, which means we will end up with V3 equals to V1 plus 2 times V1 plus 1, 2 minus 7. But wait, what's V1 and what's V2? It's a A and it's a B, so plus 2B minus 7. Okay, that is your V3. How about V4? Why am I interested in V3 and V4 in the first place? Because I have this pattern, this information here, V4 equals 2 times V3. So I should find out what's V3, find out what's V4, and substitute in. So yeah, that's why I'm finding V3 and V4. How about V4? You just have to, again, do the same procedure. You realize that n plus 2 this time is equals to 4. Or you want to force this subscript here to be a 4, which means that n is equals to 4 minus 2, 2. If n is equal to 2, we'll end up with V2 plus 2 times V, n plus 1 is 2 plus 1, which is 3, minus 7. So what is V2? It's a B. What's 2 times V3? What's V3? Oh, V3 is not A, it's not B, it's actually this guy here. Maybe I erase away this n plus 2 to be less confusing. V3 equals to A plus 2B minus 7. So substitute in over here. Open bracket, A plus 2B minus 7. Then followed by our minus 7. Simplify everything, distribute the 2, 2A plus 4B minus 14 minus 7. 4B plus B, 5B plus 2A. Maybe I like my B on the right side. So I'll get 2A plus 5B, then minus away 21. Okay, good. So now I have V3 and V4. I can now use this information here. V4 equals 2 times V3 to help me to solve the equation. So V4 equals 2 times V3, which means I can sub in the V4 with what we just found, 2A plus 5B minus 21. V4 here equals to 2 times of V3. But what's V3? A plus 2B minus 7, right? So bracket A plus 2B minus 7. All right, 2 variables, but so far we only got one equation. Wow, that means we probably have a problem, is it? We cannot solve for A and B already, because usually it got 2 variables, A and B, we need 2 equations, then can solve. But luckily in this question, if you just do the algebra, expand out the bracket, what do you get? You get 2A plus 4B minus 7. What a coincidence, something is repeated. 2A is repeated on the left and the right. So what happens? We can coincidentally cancel them off. Then we end up with 5B minus 21 equals to 4B minus 7. Can solve for B already. Just bring the 4B over, 4B minus 4B, 5B minus 4B, minus 21, bring over, plus 21, minus 7. You end up with a 14 on the right and a 1B on the left. B equals to 14. That's the answer for the first part. Okay, so we found out b to be, what was the value again? 14. So that means that your a here, that means that we still cannot find our a. That's why in part 2 here, they ask us to find an expression in terms of a, an unknown constant, for v5. We cannot solve for a. We need to leave everything in terms of a. So let's try to solve for v5 now. Do the same trick again, but this time instead of n plus 2 equals to 3, n plus 2 equals to 4, we now try to have n plus 2 equals to 5. Okay, so what will we get? We'll end up with v5 equals to v, in this case, n is 3. So vn becomes a 3 plus 2 times v, 3 plus 1 is a 4 minus 7, right? Okay, but what is v3? v3 we already found out is over here, a plus 2v minus 7. So let's just write it down. How about 2v4? 2 bracket v4, which is 2a plus 5b minus 21. Don't forget the minus 7 at the right-hand side. I mean, the last term on the right-hand side. Multiply everything out. What do we get? A plus 2b minus 7 plus 4a plus 10b minus 42 minus 7. Any like terms? Yes, a and 4a gives me a 5a, 2b plus 10b gives me a 12b, minus 7 minus 42 minus 7. I don't trust my mental sum, so I use a calculator. And I get minus 56. Then, does that answer the question already? No, because the question asks for find an expression in terms of a only. So the b must go. But we already know what's b. B is 14. The b over here must go. It must turn into a be substituted with a 14. So we will end up with 5a plus 12 times 14 minus away 56. Simplify the 12 times 14 minus 56, and we get 5a plus 112. That's our final answer for v5. Okay. Okay, now question 5 part C. The sum of the first n terms of a series is n cubed minus 11 n squared plus 4n. Straight away, when I see sum of first n terms, I am allergic to English words, so I'm going to use a symbol Sn instead. Equals to n cubed minus 11 n squared plus 4n. Now, n is a positive integer, so n more than 0, n element of integer, or more simply just element of positive integer. Then you can write it down like that. Less things to write. Okay, so means the smallest value of n is 1. The key trick you need to know here is that un, the nth term, will always be Sn minus 1. So for example, if you have Sn equals to the summation from, I don't know, r equals to 1 to n of, let's say, 5r minus 2, what does that mean? It means that you are going to substitute in the r with 1, 2, 3, 4, all the way to n. So it's 5 times 1 minus 2 plus 5 times 2 minus 2 plus so on and so forth. No space. I write it as a column. Plus dot 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 plus 5 times n minus 1 minus 2 plus 5 times n minus 2. Oh, that's Sn. But if you want the un means what? Un means the nth term. Meaning you take this, meaning you want the nth term. Here, this guy is actually your u1. This is your u2. This is your un minus 1, and there's your un. In other words, we actually want to extract out this last guy here. You could have just replaced the expression 5r minus 2 directly with n, and you can get the answer. But in this case, but that is only possible. That will only be possible if you are given the Sn in terms of a summation of something, right? Then you can use the expression and just directly substitute the r with n to get the un from this guy. However, in this question, we were not given that. Here, you don't see any summation. Which means that we have to do it in a more indirect approach to recover this last term un. how do we do it? You need to realize that there's a trick. What's Sn minus 1 instead? Sn minus 1. It just means you take the summation from r equals to 1 to n minus 1 of the same expression, for example, phi r minus 2. You basically copy and paste the exact same thing, but without the last term. Maybe I'll use a different color. Without the last term, up to the last n minus 1 term. Up to the n minus 1 term. So this is really just u1 plus u2 all the way to un minus 1. This is u1 plus u2 plus dot 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 plus un minus 1 plus un. So how can we recover the un? The clever trick here is to take the big minus the small. Or you take the sum of all these u1 to un, take away sum from u1 to un minus 1. Then you'll just be left with the last guy here, the un. Oh, so that means un equals to sn minus 1. All these terms in between will cancel off because of the minus bracket bracket minus bracket bracket. You have to distribute the minus. So all of these plus signs here will turn into a minus. And they will just cancel off with the original. But you will still have this extra phi n minus 2 that's left behind, and that will be your un. Okay. Of course, you just need to remember the formula and you're good to go. If you don't understand this, I hope you understand what's going on. You basically take the big sum minus away the small sum less by one term, and you'll be able to recover the last term, this guy, which is your un, which is what the question is asking for. Okay, so part 1, find an expression for the nth term of this series. In other words, find un. So in other words, you need to take Sn minus 1. So how do you do that? Just take, copy and paste n cubed minus 11n squared plus 4n. That is your Sn. Then you subtract away the same thing, but this time everywhere you see a n, replace with n minus 1. So it's n minus 1 bracket cube minus 11 times n minus 1 square plus 4 times bracket n minus 1, like this. Then you just need to do a little bit of algebra to expand the answer. Here you might need a bit of binomial expansion if you forgot. Okay, let's just do that. So n cubed minus 11n squared plus 4n, nothing happens. But here, when you got a minus, I think it's better if you just distribute it out. So minus n minus 1 cubed, minus minus become plus 11 bracket n minus 1 square, minus 4 times n minus 1. Copy and paste the first few terms, distribute. Sorry, maybe I'll leave the minus sign alone first, and I'll open up this n minus 1 cubed. So it's just n cubed minus 3n squared plus 3n minus 1 because of the alternating pattern. If you want to use the binomial formula, here's how you do it step by step. It's really just n plus negative 1 bracket bracket power 3. So we have 3 choose 0 n power 3 negative 1 power 0 plus 3 choose 1 n square minus 1 power 1 plus 3 choose 2 n power 1 minus 1 power 2 plus 3 choose 3 n power 0 minus 1 power 3. Then what you should realize is that power 0 just becomes a 1. 3 choose 3 is 1. 3 choose 0 also 1. Maybe you can actually key in all these values in the calculator if you really cannot memorize it. So 3 choose 1 means what? You have 3 t-shirts, you want to choose one. How many ways to do that? 3 ways. How about choosing 2 ways? You have 3 t-shirts, you want to choose 2 of them. It means that you have to leave 1 behind. Number of ways to choose 2 of them is the same as number of ways to leave 1 behind, which is really just 3 choose 1 if you count the number of ways to leave behind that one other shirt. So this will also be 3. This will also be 3. Doing a bit of permutation and combination logic. Then, yeah, of course, you can also use a formula to manually calculate that, but there's no need to. You can just use a calculator to get these values. Then n cubed n squared n power 1, you can't really do anything, but here, and here, something special happens. Negative 1 power 2 is really just positive 1. Negative 1 power 3 is just a negative 1. When you have odd power, you get negative. Same thing with negative 1 power 1. You can just ignore the positive 1 power. So what do you end up with? You get 1 times n cubed, which is n cubed. Right? This actually becomes a 1. So times 1, nothing happens. Plus 3 times n squared times negative 1 plus 3 times n times 1 plus last one is 1 times 1 times negative 1. 1 times 1 times negative 1. Simplify and you eventually get back to n cubed minus 3n squared plus 3n minus 1. Hopefully you are able to do this quickly. The pattern is really just 1, 3, 3, 1. And then because of the minus over there, you have an alternating sign, plus minus plus minus. And the pattern, there's a power of the pattern. There are two other patterns to take note of. The power of n is decreasing. 3, 2, 1, then eventually n power 0, as well as the hidden negative 1, power 0, power 1, power 2, power 3, which we have already simplified it down into the plus, minus, plus, minus. Okay, that's for n minus 1 cube. Don't forget the minus sign outside later need to distribute as well. Then plus 11 times n minus 1 squared. N squared minus 2 times n times 1, 2n, plus 1 squared, 1. Minus away, minus away 4n plus 4. Okay, continue simplifying. What do you get? Copy and paste because I have the ability to do that on an iPad, and I can distribute the minus sign now. So I will get minus n cubed plus 3n squared minus 3n plus 1. Remove the bracket. Then 11, I also can multiply in. I will end up with 11n squared. Luckily, it's a positive, so I don't have to stress so much about the plus minus sign. 11n squared minus 22n plus 11 minus 4n plus 4. Okay, then now you start to combine like terms. N cubed minus n cubed, gone. Minus 11 squared plus 11 squared, gone. What else? Maybe we look for any other cube terms or no more. Any other square terms? Have here as well. That's the only one left. So we can write down 3n squared. So after power 2, we look for power 1. Any linear terms here? Yes, 4n. There's a minus 3n. There's a minus 22n. There's a minus 4n. Maybe I should also underline the 3n squared. So now let's combine all the linear terms, the green color ones, and power 1. 4 minus 3 minus 22 minus 4. 4 minus 4 cancels. Minus 3 minus 22 is minus 25. So minus 25n. Then we move on to the constant terms, the last one. Plus 1 here, plus 11 here, plus 4. You end up with 15 plus 1, 16. Okay, then that's your answer for part 1. Moving on, part 2. The sum of the first m terms of this series, where m is a number more than 3. So m could be 4, could be 5, could be 6, is equal to the sum of the first 3 terms of this series. Find the value of m. So what does it mean? What does it mean? Okay, sum of the first m terms really just means that you start from, let's say, index r equals to 1 to m of the generic term in the sequence. In this case, which one will we use? Would we put down Sn or we put down Un? Must be Un because Un is the nth term of the sequence. Sn is after we sum everything together. You take the Un, or in this case, since I'm using the running variable, the running index r, I will replace everything I see in my Un with a letter. Every letter n with a letter r instead. The sum from 1 to m, they tell you that this is exactly equal to the sum of the first 3 terms of this series. So just copy and paste this first 3 terms. Now, what else do we know? We know that m is more than 3. So that just means m is some number. Let's say, for example, m is 5, for example. Then it means that we'll end up with a u1, u2, u3, but not enough. You still need to add them together, plus u4 and a u5. And they tell you that it's equal to this guy, which is really just un. You sum up from, ur, and you sum up from u1 to u3. They tell you they are equal to each other. So what do you know? What can you see? You see that the u1 and u1, they can cancel each other off. Likewise for the U2 and the U3. Then that means that the extra terms that goes after 3, so from 4 onwards up to the index m equal to 5, will be actually equal to 0. Oh, right? Okay, good. So that means all we need to do now is to figure out what is this in general in terms of m. So what we can do is, instead of splitting out as u1 plus u2 plus u3 and then u4 until u5, in general, it shouldn't be a 5, it should be a m. So it's u4 plus u5 plus u6 plus u7 plus dot, 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 until um minus 1, then um. In other words, we can split our summation, this guy here, into two things. Summation from r equals 1 to 3, which is u1 plus u2 plus u3, add on summation of r equals to, sorry, not 1 anymore, it's 4 to n. Then you can just put down ur here, ur, to save some time. And the right-hand side is also ur, from r equals to 1 to 3. So these two guys can cancel off, you're left with a 0 on the right-hand side. That means the summation of ur from r equals to 4 to m will be equals to 0. So, okay, so how do we express this? How do we get this expression in terms of m, then solve for n? It's a bit difficult, right? It's a bit difficult. If you try to actually substitute in I equal to 4, I equal to 5, I equal to 6, all the way to I equal to m minus 1, then I equals to m into the ur here, where you replace the n with r, that's going to be a quite difficult task. So what we should realize instead is that we can actually split this up into summation of ur from I equals to 1 to m, then subtract away u1, subtract away u2, subtract away u3. Right or not? You can split this up as the summation from 1 to m, including u1, u2, u3, and u4 all the way to dot, 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 to um. Then you take away the u1, u2, and u3. How do you take it away? By subtracting the u1, u2, and u3. Oh, what's the advantage in doing that? This guy here, summation of ur from r equal 1 to m, is just the series formula. It's Sn. Or in this case, it's actually Sm. Replace the letter n with m. Now, m is just some number. So we actually have a formula for Sn, but replacing the n with m. So all we need to do is to take that formula and replace the n with m. Okay, then you subtract away u1, u2, u3. But wait, what's u1, u2, u3? It's this one. Maybe it's nicer if I just bring it over to the right-hand side first. So u1 plus u2 plus u3. First, then after that, I sub in. So let's sub in the left-hand side first. Sm means replace the n with m. So m cubed minus 11 m squared plus 4m equals to u1 plus u2 plus u3. Then you just have to sub in. So 3 times 1 squared minus 25n, in this case 1, plus 16. Add on 3 times 2 squared minus 25 times 2 plus 16. Add on 3 times 3 squared minus 25 times 3 plus 16. Key this in a calculator, and what do you get? You get a number that is too that I'm too lazy to calculate. What you should realize instead is that over here, u1 plus u2 plus u3, isn't that actually just S3? So actually you didn't have to write this down manually. You already have a formula for S3. I mean Sn. Just have to replace the n with 3. So it's 3 cubed minus 11 times 3 squared plus 4 times 3. Calculate this instead. What do you get? 3 power 3 minus 11 times 3 squared plus 4 times 3. You end up with a negative 60. So bring it over to the other side. You end up with m cubed minus 11m squared plus 4m plus 60 equals to 0. Then you can use a GC to help you to solve. You'll end up with m equals to 10, 3, or negative 2. But since we already told you that m is more than 3, this implies that m is equals to 10 only. That's it. Okay, maybe a simpler way that I could have done this right from the beginning is to realize that Sm equals to S3. I have a formula for Sn. Just have to substitute n with m, n with 3. Then I can get the expression over here straight away. Yeah. Okay, question 6. By writing 1 over 4r squared minus 1 in partial fractions, find an expression for this summation. Okay, so this partial fraction, let's just split it up now. So 1 over 4r squared minus 1 can actually be factorized as 2r bracket square minus 1 square, which is just 2r plus 1, 2r minus 1. Then you can split it up as 1 over 2r plus 1 plus 1 over 2r minus 1. Then cross multiply, should be a over 2r plus 1 plus b over 2r minus 1. Then cross multiply. You end up with 1 equals to a times 2r minus 1 plus b multiplied by 2r plus 1. Okay, so now we just have to sub in r with a good value. Let's say positive half. What do we get? 1 equals to a times 2 times half is 1, 1 minus 1 is 0, plus b times 2 times half is 1, 1 plus 1 is 2, which means that 2b equals to 1, so b equals to 1 half. Likewise, you can sub in r with, okay, this time maybe negative half, but I think I will just sub in with 0 because we already solved for b. Any value of r will work now. So 1 equals to a times 2 times 0 minus 1, which is negative 1, plus b, which is a half, times 2 times 0 plus 1, which is 1. Which means that you get a to be equals to half minus 1, which is negative half. Okay, then I can replace the a with a negative half, the b with a positive half. Okay, good. So simplifying it, I can rewrite this as 1 over, okay, I'll swap them around. So this guy onto the left, I get 1 on top, then 2 below, but multiplied by the 2r minus 1. Then subtract away, 1 below and 2 bring down, multiplied bracket 2r plus 1. So now, partial fractions done. Now we need to find an expression for the summation from r equals 1 to n of that expression. It will just be the exact same thing, but you replace the fraction there with the difference, 1 over bracket 2r minus 1 minus 1 over 2 bracket 2r plus 1. So again, you see a summation of a difference, minus sign. It means method of difference, MOD. So if you just sub in manually with I equal 1, 2, 3, and then n minus 1, sorry, n minus 2, n minus 1, and n, you'll see all the terms cancelling off. So let's just do it. Sub in r with 1, you get 2 times 1 is 2, minus 1 is 1. Minus 1 over 2 times 1 is a 2, 2 plus 1 is a 3. That's when r is equal to 1. Next, sorry, not equal, should be plus 1 over 2 times. In this case, if I increase my r by 1, I will end up with extra 2. So that means this has to add on a 2. So it becomes a 3. Alternatively, you could just manually substitute in 2 times 1 minus 1 is a 4 minus 1, which is 3. Okay, then likewise for the other guy, it's just 2 times, add on a 2. So we get a 5 when r is equal to 2. If the r here increases by 1, I have to multiply that by 2. So that's why the net change is plus 2. That's why I went from 3 to 5 plus 2. Continuing on, the next one, if r is equals to 3, you just get 2 times 5 minus away 1 over 2 times 7. Don't forget the plus sign in front. Okay, continue. We have to show you, I have to show the first 3 and the last 3 terms to be convincing. You don't exactly need to do this, but I like to always put down the first 3 and the last 3 values of r. So I am fully convinced about what can cancel and what cannot. Okay, so let's just substitute in. So 2 times, in this case, n minus 2 minus 1. Maybe I'll just copy down the expression at the side so I can have a look at it without scrolling up and down. Yeah, so substitute in r with n minus 2, you get 2 times n minus 2 minus 1, and then have a 2 times in front. Simplify this down, it becomes 2n minus 4 minus 1, which becomes 2 times 2n minus 5. Subtract away 1 over, here it's 2 times, from minus 1 go to plus 1, means I plus 2. So the inside of the bracket's plus 2. I'm left with 2n minus 3. Continuing on, just add on a 2, you get minus 3. Add on a 2, you get minus 1. And then the last one, if you sub in r with n, you get 2 times 2n minus 1, minus away 1 over 2 times bracket, sub in r with n, 2n plus 1. Okay, then now we can see all the terms that cancel off. Here, 1 over 2 times 5 and positive 1 over 2 times 5. So sometimes the direction goes downwards, not always upwards, not always top left to bottom right. This guy can also cancel off with a hidden positive 1 over 2 times 7. This guy can cancel off with a hidden negative 1 over 2 times bracket 2n minus 5. These two cancel off, these two cancel off. You're left with the top 3 terms and the bottom 1 term. Is that right? Oh, sorry, I forgot to cancel off one more term, one more pair here. So the top left and the bottom right. Okay, simplifying this down, what we get will eventually be equals to 1 over 2 minus away 1 over 2 bracket 2n plus 1. Okay, that's our answer. Okay, that's for part 1. Hence, find the exact value of this summation, but you substitute the n with infinity, means you're taking the sum to infinity, the limit as n goes to infinity. So let's just write it down. To summarize, maybe I should write this down first. The conclusion we got from part 1 is that this summation is actually equals to half minus a fraction 1 over 2 times 2n plus 1. Now in part 2, we are expected to find out what is sum r equals 1 to infinity of the same expression. So it's just the limit as n goes to infinity of the expression, but the upper limit is n. N, then take the limit as n goes to infinity. That's what they are saying when they replace with an infinity there. So what do we know about the summation from 1 to n? It's really just this fraction minus fraction. Then this half is independent of the n, so it's not affected. So the half remains as a half as n goes to infinity. Subtract away this guy. What happens as n goes to infinity? The denominator becomes very, very big. So it's 1 over infinity, which actually essentially goes very, very close towards 0. When you take the limit, it will be exactly equals to 0. Okay, so half minus 0, and your answer will be a half. Done. Let's take a look at question 7. A sequence u1, u2, u3 is such that un plus 1 equals to 2 times of un plus a times n. A is a constant, n is more than equals to 1. Now for part 1, given that u1 equals 5, u2 equals to 15, find a and u3. How? Well, it's the same question, right? We just need to find out what's u1, u2, then u3. List them down using the given information. So u1 we already know is 5, u2 we know is 15. How about u3? This is when we should use the formula now. If n plus 1 is 3, that means n is equal to 2. So 2 times u2 plus a times 2. Take note that this is not a subscript, this is multiplication, a times n. So times 2. But what's u2? We already know u2 is 15, so 2 times 15, add on 2a. Simplify and we get 30 plus 2a for u3. How about the other terms, u4? Okay, let's just try and solve for a. Right, u2 equals to 15, but actually we could have also expressed u2 using this formula here. So u2 is actually just 2 times of the index before that, so it's u1 plus a times n, in this case is 1. But what's u1? We know u1 is 5, so we can actually replace the 2 times u1 with 2 times 5 plus a. Simplify it as 10 plus a. Okay, then actually we don't need u3. We just need to get you just need to use 15 equals to 10 plus a, which means that 15 equals 10 plus a, which means that a equals to 5. 15 minus 10. This U3 is not relevant for now. Okay, that is part 1 done. Let's move on to part 2. Part 2 is telling you that this, what we call a recurrence relation, is actually has an explicit expression, which is this guy, un equals to a multiplied by 2 to the power of n plus b times n plus c. Now, when you try to solve this for a, b, and c, you just need to substitute in with the correct value of n. In this case, we are given u1 equals 5 and u2 equals 15. So n equals 1 and n equals to 2. So we should make use of these two information to help us to solve. But maybe at this stage, because I see that there's 3 unknowns, we probably need 3 equations. So here we got u1 equal to 5 and u2 equal to 15, only 2 pieces of information. That's probably not enough. So that's when I will actually need to recover back my u3. I need this information here for my part 2. What's 30 plus 2a in this case? 2a is actually 2 times 5. So it's 30 plus 10, which is 40. Okay, good. Then how do you solve for un now? Maybe I can sub. I mean, how do you solve for the a, b, and c now? Maybe you can just sub in n with 1. Then you get u1, which you know is equal to 5, equals to a times 2 power 1 plus b times 1 plus c. So now you have an equation in terms of a, b, and c. 2a plus b plus c equals to 5. Next, if you sub in n with, let's say, 2, what do you get? You get u2, which is given to be a 15, which is equals to, if you use the formula now, replace the n with 2. So 2 to the power of 2 plus b times 2 plus c. But just a reminder, u2 equal to 15 was given by the question. Simplify. Now, 2 squared is 4, so we get 4a. 2b is just 2b, so plus 2b. Add on a c equals to 15. That's your second equation. So I'll call this equation 1, equation 2. Then you realize 3 unknowns. So you have 2 equations. Is it enough? Not enough. You need a third equation. 3 equations, 3 unknown. 4 equations, 4 unknown. 5 equations, 5 unknown. Then you can solve for the variables. So have a unique solution for each letter in the system of equations. So if you sub in n now this time with 3, what do you get? You get u3, which we already calculated as 40, right? U3 is 40. So that means 40 is equals to a times 2 to the power of 3 plus b times 3 plus c. Okay, now simplifying, what do we get? 2 cubed is 8, so 8a. 3b is just 3b. C is just c, equals to 40. That's your equation 3. To make things look neater, I'm going to combine them all together side by side. So equation 1, equation 2, and finally equation 3. Put them all side by side, just to make it look a little bit neater, so it's easier to key in the calculator. So typing in the calculator, what do you eventually get? 15 over 2 minus 5 and minus 5. Sorry, not z, should be c. Okay, then that's part 2 done. Find next part 3. Find the summation of ur from r equals 1 to n in terms of n. You don't need to simplify your answer. Okay, can. So we already have an expression for un here, but here they gave you ur. So you just need to replace the n with r. Okay, that's what we're going to do. So, and also replace the a, b, and c. So let me just copy down the un first. So for part 3, I need to copy down the un, but maybe just to make my life easier, I'll replace the n with r. Don't need to think so much, just replace straight away. And how about a, b, and c? What is it? We got 15 over 2, so write that down. We got b, which is minus 5. And we got c, also minus 5. I'll make it look a little bit neater. So minus 5r, minus 5. Okay, now we want to take the summation of this guy from r equals 1 to n. So just take the summation of the entire thing on the right-hand side, r equals 1 to n. Now you can take a summation. Whenever you take a summation, you can take it term by term, just like integration. You can integrate term by term or differentiation. And you can even factor out the common factor of 5. So you get minus 5 times summation of r from 1 to n, minus away 5. This one have to be careful. You can take the summation from r equal 1 to n of 5. Let's just evaluate each one piece by piece. Here, 15 over 2 can actually be factored out. So I'll just factor it out first. Then I'll be left with 15 over 2 multiplied by summation of this guy. What is this guy? 2 power 1 plus 2 power 2 plus 2 power 3 if I just replace all the r values until 2 power n. What is this? Times 2 times 2 times 2. So this is actually just a geometric series, right? Then the formula for geometric series, what is it again? Sn, maybe I should label here geometric series. When I say series, I mean I'm adding up all the terms. Sequence means it's term by term, separated by commas. Series means you plus everything together. So the formula here is a times 1 minus r power n, all divided by 1 minus r, where a is your first term, r is the common ratio, n is the number of terms. So let's just do that. 15 over 2, you leave it alone. Take the summation, what do you get? You get a first term, sub in r equal to 1, you get 2 power 1, which is 2, multiplied by 1 minus r to the power of, sorry, the r is not r anymore, it should be a 2 to the power of number of terms. When you take summation from 1 to n, how many terms are there? Upper limit minus lower limit plus 1 equals to n. So power n, all divided by 1 minus the common ratio. What's the common ratio? It's a 2. Close the bracket. Minus away 5 times summation of r. What is this? What is this? If you sub in r equal to 1, I equal to 2, I equal to 3, then you put plus sign in between. It's 1 plus 2 plus 3. So the dot until plus n. The common difference of plus 1 plus 1 plus 1 tells you that this must be your arithmetic series. So what's the formula for arithmetic series again? I'm sorry, I'm using the same Sn. I hope you are not confused. Sn for geometric series now is Sn for arithmetic series when you have a common difference. So it's actually just n over 2 multiplied by a plus l, where a is the first term, l is the last term, n is the number of terms. N over 2 multiplied by, what's the first term? A is just a, but last term is actually the nth term in, if you recall the arithmetic sequence, it's un equals to a plus n minus 1 times d. When you take a summation r equals to 1 to n, when the index r equals to n already, that is your last term. So using this formula, the n is already there. So that means that you can actually replace the l with the nth term, un. But we know what is un. It's just a plus n minus 1 times d. So this is another formula, or another version of the formula for Sn. But this first one, I would prefer it because it's quite easy to find the L without knowing all these formulas. You just need to look at your expression, the R, right? Then substitute in with the last index number for R equals to n. So that means that this is really just 5 multiplied by n over 2, which is like that. Take note that the n is not always n. In this case, n here is actually referring to the number of terms, and upper limit n, lower limit 1 means you have number of terms being n minus 1 plus 1, which is coincidentally the same as n. You don't just read off n at the top, then therefore n here as well. No, you need to count the number of terms. So a quick example would be if you take a summation of r from r equals to 3 to 5. Is it 5 over 2 times first term 3 plus last term 5? No, because here it's wrong. It shouldn't be 5. It should be 5 minus 3 plus 1, which is 3. Okay, anyways, continuing on, you get first term, which is 1, plus the last term sub in with n. So n, close the bracket. That's how you get this guy to be that guy. And the last part, minus the summation of 5 from r equals 1 to n. Since this one doesn't have an r, does it mean it becomes a 0? No, it means that you have to take this 5, but you copy it n times. From r equal to 1, it's a 5, r equals to 2, it's another 5, r equals to 3, it's another plus 5, so on and so forth, until r equals to n, you have to add on the last 5. How many copies of 5 would there be now? n copies of 5. So it's really just 5 times n. Sorry, minus 5 times n. Okay, and that's how you get this the expression here. Then now we just have to simplify. 1 minus 2 is negative 1. 2 and 2 cancel off. You're left with negative 15 in front, multiplied by 1 minus 2 power n. Maybe you can simplify a bit more. Minus bring in, then you get 15 multiplied by 2 power n minus 1. Actually, at this stage, you should look back at the question. Look back at the question. And then you realize, oh, they told us you need not simplify your answer. You need not simplify your answer. So that means that we should just leave our answer alone. At this stage, don't do any extra work. That's it. That's your answer. Okay, next question. Okay, 8 part A. A sequence of numbers U1, U2, U3 has a sum Sn, where Sn equal to summation UR from I equal to 1 to n. Okay, yeah, that's just how a summation works. It is given that Sn equals to an squared plus bn. Okay, this is new information, unique to this question, where a and b are non-zero constants. Find an expression for un in terms of a, b, and n. So it's the same trick again. How do you go from Sn, convert into un? What's the formula? un, a part 1 already, equals to Sn minus away Sn minus 1. All the terms, the long terms, minus away the short terms. The short sum, sorry. Index 1, index 2, index 3, until index n minus 1, index n. That's sum n, sum from 1 to n. Then sum from n-1 to n minus 1 is just this guy. This bottom part is Sn minus 1. The top part is Sn. Then if you take the difference, you minus away, what happens? You're left with the extra portion here, which is just your un, the nth term. Okay, so knowing that, we can now use the formula. Then we just need to substitute in the Sn with an squared plus bn. Just make sure that you don't put a subscript for the n here. Then minus away, bracket, a bracket n minus 1 square plus b bracket n minus 1. Make sure you have the brackets so you can distribute the a, distribute the b later. And also another pair of brackets outside so that you can have a minus to be distributed later. Bracket here and bracket there. Moving on, an square plus bn, minus away, multiply out. Then you get minus a times n square minus 2n plus 1. Then minus must again distribute into plus b, become a minus b times n minus 1. Simplify now, an square plus bn minus an square plus 2an. Right, why plus? Because minus. Then minus times 1 become minus 1, minus bn plus b. Good. Combine like terms. I see an square minus an square cancel each other off. I see bn, I see 2an, I see minus bn. Bn cancel off, you're left with a 2an. I see there's a negative 1, there's a plus b. Don't cancel off, so just copy down. Let's read the question again. What did they say? Find an expression for un in terms of a, b, and n. A, b, and n. Okay, good. My expression is done. Maybe just to make it look a bit neater, it's a times n, not a subscript n. Okay, that's a part 1 done. Moving on, part 2. It is also given that the 10th term is 48 and the 17th term is 90. I am allergic to words, so I will write it as n equals 10 and n equals to 17. Then I know that the U10 must be equal to 48 and U17 must be equal to 90. Okay, much better. Then what else? Knowing that, what should we do? Find A, find B. Okay, so solve for capital A and solve for capital B. So using this information, I can just substitute in the value of n and the value of the un. Okay, so since U10 equals to 48, this means that 48 is equals to 2 times A times n, in this case is 10, minus 1 plus B. Simplify, we get 48 equals to 20A plus B minus 1. Bring the minus 1 over, we get a plus 1, which is 49. So 20A plus B equals to 49. I'm purposely writing it this way so that my A is on the left, B is on the right, number is on the right hand side. Okay, then next, since U17 equals to 90, this implies that 90 is equals to 2 times A times N is 17 minus 1 plus B. I'm looking at the formula here. Then I replace the N with 17. Then the U17 is 90. Okay, good. So now I have a second equation in terms of A and B. So simplify. (34A minus B equals to, sorry, should be just plus B. I'll leave these two alone and I'll swap them around. But the minus 1 I bring over become plus 1. So 90 plus 1 is 91 over here. Equation 1, equation 2. Then just use a GC or scientific calculator also can. Then what do you get as your answer? You will get A equals to 3 and B equals minus 11. Okay, good. So yeah, that's it for this question part. Then now move on to the next part, part B. Show that R squared times R plus 1 bracket square minus away R minus 1 bracket square times R square equals to K times R cubed, where K is a constant to be determined. Use this result to find a simplified expression for the summation of R cubed from 1 to N. Okay. So let's just work with the left-hand side first. Because I see there's a left-hand side, there's a right-hand side. Show question means you either go from left to right or right to left, or left guy meet in the middle, right guy also meet in the middle. Middle are both the same, then you can conclude that they are equal, and you would have shown that equation is true. But here I see that the left-hand side is more complicated. Right-hand side KR cube is already quite simple. So I will go from the more complicated towards the easier side. So left-hand side first. Let me copy down the left-hand side first, and then I will proceed to expand everything. So R square, then you have R square cannot do anything, so leave it alone. But the R plus 1 bracket square, you can do something. R square plus 2R plus 1. Then minus away, something times R square. This something is a binomial square, so again, you can expand. A square minus 2AB plus B square. R square minus 2R plus 1. And continue distributing. R square times R square, you get R power 4 plus 2R power 3 plus 1 times R square is R square, minus away R square times R square, which is minus R power 4, minus away R square times minus 2R, which is a positive 2R cubed, minus away R square times 1, which is minus R square. Simplify, we get R power 4 minus R power 4. Good. 2R power 3 plus 2R power 3, which is 4R power 3, and then R square minus R square, which means you're left with 4R cubed. And this means that is your KR cubed. So you can just say where K equals to 4. Answer. Okay, now using this result, find a simplified expression for the summation of R cubed from R equals to 1 to N. Okay, so the variable here is R and the upper limit is N. How? What we realize is that R cubed looks very similar to our answer of 4R cubed, right? So we can actually divide by 4 and multiply by 4. Very similar to integration, right? You multiply and divide by the same thing. Then over here, you got a summation of 4R cubed. Well, isn't that just the summation of this expression over here? Because 4R cubed is equivalent. Yes, so we can just replace it with 1/4 times the summation R equals 1 to N of the expression that was given to us. Oh, okay, interesting. If you put on a dx, it looks like integral already. But not really. It's not, no, but don't do that. It's not the same. Not the same. But why does it look so similar? Not sure why. 3-month sum. Okay, never mind. So we continue taking the summation of this difference. What will we get? We get 1/4 multiplied by sum of the first term minus way sum of the second term. So sum of R square times R plus 1 bracket square, R equals 1 to N, minus way sum of R minus 1 bracket square times R square. Actually, at this stage, I realized, oh, no, I shouldn't do that. That won't help me. Why? Because I see that there's a subtraction here. and immediately and along with a sum. So immediately I can think of method of difference. You should just manually substitute the r now. So let's just do that. Substitute r with 1. What do we get? 1 square times 1 plus 1, which is just a 2 square, minus away 1 minus 1, which is 0 square, times 1 square. That's r equal to 1. Don't forget that I open a square bracket here. So I still need to close the square bracket later at the far right, at the bottom. After that, you just have to add on increment r by 1. So now r is 2. So 2 square multiplied by r increment by 1. So it's 2. 2 plus 1 is 3. 3 bracket square. Minus way increment r by 1. So you get 1 square. Increment r by 1, you get a 2 square. Continue, you get 3 square times 4 square minus away 2 square times 3 square. Pattern here is 1, 2, then 3, 2, 3, then 4, 0, 1, then 2, 1, 2, then 3. You're just plus 1, plus 1, plus 1. Okay, next. That's for I equal to 3. Continue. We get the r equals to n minus 2. We'll calculate the r equals n minus 2, r equals n minus 1, as well as the r equals to n term. So let's just do that. If I replace the r with n minus 2, what do I get? Let me see the expression. I cannot remember. So I will copy and paste it at the side for reference. So I don't need to keep scrolling up and down. If r is n minus 2, I'll get n minus 2 bracket square, n minus 1 bracket square, minus wait, n minus 2 minus 1 is n minus 3 bracket square, and r square is n minus 2 square. Add on the next one, sub in r with n minus 1 square, n minus 1 plus 1 is n square, minus way, n minus 1 minus 1 is n minus 2 square, r with n minus 1, n minus 1 square. So the pattern repeats, plus 1, plus 1, plus 1, plus 1. And finally, plus 1, plus 1, plus 1, plus 1. Okay, good. Now, start to see any, oh, sorry, the close bracket, I should move up a bit. So we try to find any things that can cancel each other off. Right over here, 1 square times 2 square, 1 square times 2 square, plus and minus. So they will cancel each other off. Draw a straight, continuous line like this to cancel them off. Likewise for 2 square, 3 square. Likewise for 3 square, 4 square. And the n minus 3 square, n minus 2 square. And the n minus 2 bracket square, and n minus 1 square. And the n minus 1 square, n square. Finally, you're left with the top half and the bottom half. Top cheese and the bottom cheese. You are left with 1/4 multiplied by n square times n plus 1 bracket square, minus away 0 square is just 0. 0 times anything is 0. So minus 0. So this means that you have this formula now. N square times n plus 1 square, all divided by 4. That's the simplified formula. Shown. Okay, they didn't give us the formula. You just have to simplify it on your own. Okay, good. That's part B done. Let's move on to the next question. Part C. There's a certain ratio test. This is a famous mathematician who lived a long time ago, the Lambert ratio test. It states that a series of the form summation of AR, where R goes from 0 to infinity, it converges when the limit of the n plus 1 term divided by an, which is really just a ratio. Right? If you divide things, you're finding the ratio. And you take the modulus, so you make sure it's positive, and you take the limit as n goes to infinity, and this limit is less than 1, and diverges when this okay, let me try again. This series has two possibilities. It will either converge, diverge, or be inconclusive. Converge, diverge, or be inconclusive when you use this test. What you do is you calculate an plus 1 divided by an, and then you take the modulus, and you consider the limit as n goes to infinity. There are three possibilities. This entire thing, this limit, can either be less than 1, and you conclude that the series here, the sum to infinity, is a convergent series. Or if it's more than 1, you will say that it diverges. Or last one is when it's exactly equal to 1, the limit is exactly equal to 1, then this series, sum from r equal to 0 to infinity of AR will be inconclusive. You cannot deduce anything. So using this test, explain why the series of x power r divided by r factorial as you go from 0 to infinity converges for all real values of x, and state the sum to infinity. In other words, you want to calculate the infinite sum as infinity of this guy in terms of x. Okay, so let's do that. Let me copy the question first. Okay, so this question is actually not really related to part A or part B, so we can restart from scratch. So summation of x power r over r factorial as r goes from 0 to, let's say, n, and then you take the limit as n goes to infinity. That is what they are referring to when they talk about this series. Sum from r equals to 0 to infinity of x power r over r factorial. So you need to explain why this series will converge. So from those three conditions, let me just summarize it again. Summation AR, a generic half term, like instead of UN, it's AN, and instead of using N, they use the letter R. On the half term, then you take the summation from I equals 0 to N. This series, you have three behaviors. It's either converge, diverge, or you cannot conclude anything. Question mark. Inconclusive. Cannot conclude anything. The correct way to write this, to summarize what they just said, is that if the following happens, you take the limit as an plus 1 over an modulus as n and take the limit as n goes to infinity. It is, let me just draw it as a table. If that limit here is less than 1, then we can conclude that it converges. The summation converges. If it is more than 1, then we conclude that it diverges. Limit, if more than 1, then we conclude it diverges. And the last one is when it's equal to 1, it will be inconclusive. Means we don't know whether this summation will diverge or converge. We need to use other techniques to do it, to deduce the behavior. Take note that a bit of logic is required here. If then you cannot work backwards. It's not always true. So don't need to spend too much time worrying about that. Just know that less than 1, then you can conclude it converges. So this is how so the question is asking us to show that it converges, which means we need this as our conclusion. So what do we need to show? We actually need to just show this part here, what we call the premise. The premise. We need to show that this premise is satisfied. The limit of the modulus of an plus 1 over an as n goes to infinity, this fellow here, is less than 1. So all we need to do is to calculate this guy, show that it's less than 1. Then we just have to quote by the whatever ratio test, therefore it converges. That's all. So that's what we're going to do now. Tell me what is an. It is actually just x power n over n factorial. Then because you see here is AR, then it becomes an plus 1 and an. So what is an plus 1? It's x power n plus 1 over bracket n plus 1 bracket factorial. So now you need to calculate an plus 1 divided by an. So what's that? Okay, just have to divide. So an plus 1 is actually, you just basically take this guy but replace the r with n plus 1. And for an, it's this guy replacing r with n. Then now when we want an plus 1 over an, we just take the guy where we replace with an n plus 1, divide by the guy we replace with an n. So just copy and paste now. You need to draw a huge fraction. You probably need more space. Then an plus 1 is this fraction, copy and paste it here. An is that fraction, copy and paste and put it at the bottom there. So how do we simplify this? 2 over 3 all divided by 5 over 7 is equivalent to 2 over 3 divided by 5 over 7, which is the same as 2 over 3 times 7 over 5, which becomes 2 times 7 over 3 times 5. Essentially, what happens is that the 7 went up to join the 2, so it becomes a 2 times 7. The 3 went down so that it joins the 5, becomes a times 3. So that's what we're going to do. Likewise, just that instead of 2, 3, 5, 7, we have x power n plus 1 factorial, x power n factorial. Maybe I color code it. Purple, blue, gray, and orange becomes purple, orange, blue, gray. So same thing here. Purple, blue, gray, and orange will be equal to what? Purple, x power n plus 1 multiplied by orange, which is n factorial, blue, which is n plus 1 bracket factorial, times gray, which is x power n. Color code. Okay, good. Then now we can proceed to simplify this. So what you notice is that x power n plus 1 and x power n, right? Isn't x, that's just, you can just divide, right? Because here you got the same base x, different power. So what do you do to your powers? You just have to n plus 1 minus away n, which simplifies into just an x. In other words, you're only left with a single x on top. How about n factorial over n plus 1 factorial? This one have to be a bit trickier. N factorial is just n times n minus 1 times n minus 2. Like for example, 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. Why did I pick such a big number? How about, but the more important point to take note of is that if you can see, is to take note of this pattern. You see, 6 times 5 times 4 times 3 times 2 times 1. Isn't that just 6 factorial? So 7 factorial is 7 times 6 factorial. Right? How about 9 factorial? 9 factorial will be, maybe I go to 8 factorial first. 8 factorial will be 8 times 7 factorial. Right? Just take out one of the 8s. How about 9 factorial? It will be 9 times 8 factorial. Right? Just take out the first number, then drop by 1, minus 1, then factorial. That's a pattern. So now how about n plus 1 factorial? N plus 1 factorial at the denominator. Isn't it just n plus 1 first, then you multiply by n factorial? Exactly. So that means that you can cancel off the n factorial now, get 1, 1, simplify into 1 over n plus 1. So at the bottom here, we just have a single n plus 1 factor. Make sure you got a bracket. Then how about, then that's all. That's all. Then what else we need? Remember the formula that was given to us, or the theorem, what we call theorem. The premise here and the conclusion. We want to show that this whatever series x summation x power r over r factorial summation as n goes to infinity converges, which means that we need to satisfy this premise here. If the limit as n goes to infinity of the modulus absolute value of an plus 1 over an is less than 1. So what else do we need? Maybe I just take a screenshot of this and bring it down so I don't need to keep scrolling up and down. What we currently have is an plus 1 over an equals to x over n plus 1. But what do we actually need? The modulus and the limit. So that's what we're going to do. Take the modulus. Take the modulus. But wait, what's n plus 1? N is really just the going towards infinity, right? You see, eventually. So that means that n is already positive. So n plus 1 will be even more positive. So that means that this guy here is already positive. The modulus property tells us that we have to split up the modulus into the top and the bottom. But since n is already positive, it's going towards infinity, so it's positive already. Very, very big positive number. If you plus 1, it becomes even bigger. So modulus of a positive doesn't really do anything to it. So that means this simplifies down into modulus of x divided by just n plus 1. Right? Now, we have to consider what happens if we take the limit as n goes to infinity of this fellow now. Right? Remember, we have to take the limit as n goes to infinity. So that's what we're going to do now. Take the limit as n goes to infinity of this expression. I'm just going to copy and paste to save time. It will be equals to limit as n goes to infinity, copy paste the expression to save time. Like this. So if n goes to infinity, the denominator goes towards infinity. You're dividing by infinity. What do you think this will be equal to? This must be equal to 0, right? Okay, good. So that means that the x here, probably it will not, let me just see the condition for x. Okay, the x is all real values. So yeah, this will just be equal to 0. It doesn't matter. Take the modulus of the real number. It's just a real number, but it cannot beat infinity. Infinity is super big. So the denominator is huge, which means that this eventually will go towards 0. This goes towards 0. Good. Then that means, is it less than 1? Yes, it's less than 1. So from this, from what was given, whatever was given, we have satisfied the premise of if then statement, which means that we can then conclude, therefore, this series is convergent by the ratio test, the Lambert. Ratio test. Okay, that's all. Just show that the limit of the limit of the modulus of this guy is equals to a number that is less than 1. Then we conclude by this ratio test that it is convergent. Okay. Okay, now this one, question 9, part 1, proof by method of mathematical induction is in further math. It's no longer required in H2, so please ignore this. For part 2 onwards, it's still doable. Let's take a look. So you have a sequence U0, U1, U2. U0, U1, U2, dot, dot, dot. It's given by first term U0 equals to 2. And then afterwards, subsequently, UN equals to UN minus 1 plus N cubed plus N. N is more than or equals to 1. Also from U1, U2, U3 onwards. So how do you find U1? Well, you can just use the formula by substituting N with 1. Right? It's allowed because N is more than or equals to 1. So replacing N with 1, we get 1 minus 1, which is 0, plus 1 cubed plus 1. But what's U0? It's just 2. Then the rest is just 1 plus 1, which is really just 5. Okay, that's U1. How to find U2? Same thing. Just have to replace the N with a 2 now. You see N here? It's 2. Luckily, they gave us N, not N plus 1, so we don't have to scratch our head so much. So N is just 2. Then you just replace N with 2. You get 2 minus 1, which is 1, plus, in this case, N is 2. So 2 cubed plus 2. Maybe I should separate it a little bit more. Yeah, so U1 is what? U1 is 5. So we add on a 5, type in a calculator, 5 plus 8 plus 2, 10 plus 5, 15. Okay, good. Then how about U3? U3 is just U2 plus 2. Sorry, no, the N in this case is 3. 3 cubed plus 3. So what's U2? 15. What's 3 cubed? 27. What's 3? It's just 3. Okay, honestly, you don't need to simplify 27. Just key in the calculator and you get the final answer, 45. Good. Moving on. So by considering the summation of UR minus UR minus 1, take the sum from I equal to 1 to N, find a formula for UN in terms of N. Whenever you see summation, you see minus sign, you must think MOD, not Ministry of Defense, is method of difference, telescoping sum. So in this case, what do you see? Where's UR and UR minus 1? It's really here. It's really just here. But you must replace the N with R, and then you must bring the UN minus 1 to the other side. So let's take a look. I'm just going to copy down the question first. Hold on a second. Okay, so how do you get the UR and UR minus 1? You basically take the UN formula, you replace the N with R. So UR equals UR minus 1 plus R cubed plus R. Okay, then where's UR minus UR minus 1? It's right over here, but you just bring over the UR minus 1, bring over. Then you will obtain your UR minus 1 equals to R cubed plus R. Okay, good. So now also we need to quote the formula that we had from the previous line, from the part 1. So for this H2 math current syllabus, you just have to assume that the formula here is already proven to be true. Assume true. Then we'll learn to use that formula. So Now that we have this expression for ur minus 1, r cubed plus r, all we need to do is to take the summation of r from r equals to 1 to n. I'll just move it over to the side so I have more space. If you take the summation from r equals to 1 to n on the left, you need to do the same on the right side. So that means that I'll have summation of r cubed plus r. Wait. Isn't that just r times r squared plus 1? Right? Okay. This looks very familiar. Oh, right. It's right over here. It's from part 1. So we can just use the formula and then substitute in. So it's just 1/4 n multiplied by n plus 1 multiplied by n squared plus n plus 2. Okay, then that's it. We have found our formula. Right? No, this is actually the summation from ur minus 1. We actually wanted un on its own, the nth term. So what should we do? Whenever you see summation, you see minus, you must think MOD. So you need to go and sub in manually from I equal to 1, 2, 3, then n minus 2, n minus 1, n, so that you can see all the things that cancel off. So that's what we're going to do. Maybe I'll just bring this over to the far right side so I have more space. Take the summation of this guy, ur minus 1, sub in all the values of r. So let's just replace r with 1, r with 2, r with 3, then r with n minus 2, r with n minus 1, then finally r with n. We'll see what we get. u1 minus u0 plus u2 minus u1 plus u3 minus u2 plus dot 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 plus un minus 2 plus un minus 3 plus un minus 1 plus un minus 2 plus un plus un minus 1. Wow, finally done. Please don't fall asleep. u1 minus away u1, they cancel each other off. u2 minus u2, cancel. Am I going too slowly? That's why I'm gonna fall asleep already now. Okay, so this one and this one are the two terms that remain, which means that you are actually left with un minus u0 equals to the right hand side 1/4 multiplied whatever, copy and paste the answer from part 1, making use of the answer that we got from part 1. But wait, what's u0? Look back at the question. u0 equals to 2, the initial value. Oh, so u0 equals to 2. Then we can go back here and replace the u0 with a 2. Then finally, we solve for un to be 2 plus 1/4 whatever. No need to simplify. Just leave it. This is perfectly fine. Your final answer. Yeah, that's all. Okay, let's take a look at question 10. So this part, again, mathematical induction is no longer in the syllabus. Let's just move on to part B. We may need to use the answer from part A. We'll see. So from B part 1, show that the fraction 2 over 4r squared plus 8r plus 3 can be expressed as a over 2r plus 1 plus b over 2r plus 3. So basically, it's just asking you to do partial fractions. Alternatively, you can just let a and b be that guy, and then you just cross multiply and solve simultaneous equation. But they didn't give the value of a and b. Okay, you need to solve for a and b, so no choice. You really have to do partial fractions. So what you should realize is that the denominator can be factorized. If you just key into the calculator and equate the denominator to 0, and you try to solve for r, you'll get r equals -half, r equals -3/2. So you just have to multiply over. Then you get 2r equals -1. Bring the r -1 over, you get 2r plus 1 equals 0. Likewise over here, 2r equals -3, so 2r plus 3 equals 0. Here are your two factors, 2r plus 1, 2r plus 3. Bracket 2r plus 1, 2r plus 3. Then you can do a logic check. 2r times 2r gives you 4r squared. Is it the same? Good. Okay, then you must be on the right path. You can check the rest on your own. That it should be correct. Okay, then you take this, you split it out as these two partial fractions. Always go 1 degree lower than the distinct linear factors. Sorry, this should be a plus 3. Okay, continuing on, we just need to solve this partial fraction. So just cross multiply. So 2 equals to a times 2r plus 3 plus b multiplied by 2r plus 1. Then maybe we can sub in r with, let's say, I don't know, -half. Yeah, so this will become a 0. So that means we have 2 equals to a times negative half times 2 is negative 1 plus 3. Actually, that just simplifies to a 2. Add on b times, if r is negative half, 2 times negative half is negative 1. Negative 1 plus 1 is 0, so we get a 0 over here. This implies that 2a equals to 2, so a is equal to 1. Now we sub in r with, let's say, positive. Let's say if I equate this to 0, what will I get? Negative 3 over 2. Let's say I replace with negative 3 over 2. What do I get? 2 equals to 0 plus b times 2 times negative 3 over 2 gives me minus 3 plus 1 gives me minus 2. So that means my b is equals to negative 1. Okay, good. So that means that a can be replaced with 1, b can be replaced with minus 1. That's good. The minus can also be brought forward here, so it becomes a minus. What's so good about doing this? You get a positive fraction, you get a negative fraction. And then let's take a look at b part 2 now. The sum of this fellow here that we just found, the partial fractions to, is denoted by Sn. Find an expression for Sn in terms of n. Okay, good. So that just means b part 2 will be take the sum r equals to 1 to n of whatever we just of the fraction we were dealing with just now, but now you replace that fraction with the partial fractions. So 1 over 2r plus 1 minus away. I'll just make this look a bit nicer. 1 here minus 1 here. Straight away you see fraction minus fraction summation. As a minus means that you have to use method of difference. Sub in 1 by 1. I equals to 1, I equals to 2, I equals to 3, I equals n minus 2, n minus 1, n. So that's what we're going to do. I equals to 1, I equals to 2, I equals to 3. Do that. So 2 times 2 plus 1 is a 4 plus 1 is a 5. Minus away 1 over. From plus 1 to plus 3, you have to add 2. So 5 plus 2 is 7. And add on, next one. If you increase r by 1, you increase by 2. So 5 plus 2 is 7. Minus away 1 over. How do you go from plus 1 to plus 3? Plus 2. So that likewise, 7 must also go to the next guy, 9. 7 plus 2 gives you the 9. Sub in r with 3, you get 9 minus away 11. 1 over 9 minus 1 over 11. Carrying on with r equals to n minus 2, n minus 1, and n. Eventually, you will get to these last 3 guys. Okay, then moving on. So we realize that there are a few things that can cancel off. 1 7 minus 1 7. 1 9th minus 1 9th. Minus 1 11th and positive 1 over 11. Likewise for the 2n minus 3 denominator, 2n minus 1 and then 2n plus 1. So you are left with the top guy and the bottom guy. So what's this equal to? 1 over 5 minus 1 over 2n plus 3. That's your answer. Okay, that's for B part 2. Moving on. So B part 3 requires us to find the smallest value of n for which Sn is within 10 power negative 3 of the sum to infinity. Okay, so what is the sum to infinity? It's just S infinity, which is really just, if you remember, the limit as Sn, the limit of Sn as n goes towards infinity. Let me write it neatly. N arrow infinity. Yeah. So what is this guy? It's just lim n goes towards infinity. Lim stands for limit. It's the maximum limit. So Sn in this case, we already found the answer. 1/5 minus 1 over 2n plus 3. So just think about it. As n goes to infinity, what happens to your fraction over here? Goes towards 0. So 1/5 minus 0 equals to 1/5. Okay, good. That's your answer. But wait, no, that is just the sum to infinity. They said you want the smallest value of n so that the Sn is within 10 power negative 3 of the sum to infinity. What does that mean? So Sn here is equal to, let's copy down the expression. And you want this guy to be within 10 power negative 3 of the sum to infinity. So that just means that you need this part here whenever as you increase the value of n, right, you're basically subtracting a smaller and smaller fraction. Eventually, you're subtracting minus 0.000000001 and then 1/5 minus. So it's very, very close to 1/5, but just slightly under the 1/5. As because n value is positive, so this fraction will also be positive. Positive 1, the numerator here is a 1, which is positive. If n is positive, 2n will be positive. You add on a 3, it will be even more positive. So positive over positive still gives you positive, but you minus away a positive. Means that you're always 1/5 minus away a tiny little bit, maybe 0.001, for example. Yeah, so how do you make sure that it's within 10 power negative 3? It just means that this part is the one who's causing the trouble. Sn wishes to be exactly 1/5, but it's always dragged down by this 1 over 2n plus 3. The minus 1 over 2n plus 3 is dragging it down. So it's very, very close to 1/5, but just always slightly under. So that just means you need this 1 over 2n plus 3 to be equals to that 10 power minus 3. Okay, then from there you solve for n. Yeah, from there you solve for n. So how do you do this? You can actually use a GC. Hold on, let me show you. Okay, so maybe one way to do this would be 1 over 2n plus 3. You flip it upside down first. So you're basically taking power -1 on both sides. So this becomes 10 power positive 3. Then what you're doing next is you can actually, you don't need a GC, just 10 power 3 minus away 3, then divide by 2. Then you can solve for n. So that's 1000 minus 3, which is, never mind, you can just use a calculator for this. 1000 divided by 3 minus away 3, then you divide by 2. 997 over 2. And that is 498.5. So here, the n, the problem is that it must be an element of integers, positive. So that means that would you want to round up or round down in this case? Here we want, if you think about it, if you round up, right, it becomes 499. What happens to your value of Sn? When we say we want to keep it within 10 power negative 3, it means that it can be at most 10 power negative 3. You can allow this to be smaller so that you subtract away a smaller number so that it's closer to 1/5. That's better. Getting closer to 1/5 is better. So that's why we would want to make sure that in order for this fraction to be as small as possible, we want this n to be as big as possible. So intuitively speaking, we would want the n to be as big as possible, which means you need this 498.5 to be as big as possible. So you round up or down? Round up. You should get 499. Another way that you can interpret this is right from the beginning, you should think of it as Sn take away the S infinity. The distance between them should be less than 10 power negative 3. But that is a little bit more complicated, which is why I didn't explain it first. So let's just work with that instead. So what is Sn minus Sn S infinity? It's just 1/5 minus 1 over 2n plus 3. But you take away the S infinity, which is 1/5. And the distance between them, modulus, so it can be positive or negative distance, less than 10 power negative 3. This simplifies into -1 over 2n plus 3 modulus, less than 10 power negative 3. You can split this up as mod -1, mod 1 over 2n plus 3 times them, less than 10 power negative 3. Mod -1 is just +1, so it's just, if you simplify it down, 1 modulus of 1 over modulus of 2n plus 3, less than 10 power negative 3. But what's modulus of 1? Wow, it looks very, very bad. It looks like 111. Oh, it's just a single 1, just a single 1. Then how do you solve for n now? Maybe we can flip both sides of the fraction. So modulus 2n plus 3 over 1 will be 1 over 10 power negative 3, which is 10 power positive 3. But every time you flip a fraction, what happens to your inequality? You also need to change the direction. Okay. So now we need this expression to be more than 10 power 3. That means you either have, this is just 1000. When you want to open up, okay, so it's really just 2n plus 3 modulus more than 1000. That means that you actually need 2n plus 3 to be less than -1000, or 2n plus 3 to be more than +1000. Now, if 2n plus 3 is less than negative 1000, you solve for n, what will you get? You get a negative 1003 divided by 2, which is definitely negative. N less than negative does not satisfy the condition that it has to be a positive integer. So this is immediately ignored, rejected. You focus on this guy, 2n plus 3 more than 1000, which means n is more than 997 over 2. 997 over 2 more than means we have to round up, which is what I did at the start. Just pretend that this is an equation, and then you round up using a bit of intuition, avoiding inequalities. If you really want to do it formally, you will have to work with modulus and inequalities, which is a little bit difficult. Yeah. So, and you have to eliminate this case because you know n should be positive. Eventually, you get to n more than 997 over 2, which means you need to round up to the nearest whole number. So 499. Okay. 499 is your answer. This is question 11. Let's take a look. Sequence P1, P2, P3 given by P1 equals something, Pn plus 1 equal to 4, Pn minus 7, n more than equal to 1. Use the method of mathematical induction to prove that Pn is equal to 1/3 7 times 7 minus 4 power n. This is also no longer in the syllabus, so ignore part 1. But for part 2, you can actually solve it using the answer from part 1. Assume that it's true. So sum from I equal to 1 to n of PR. But what is PR? It is just the expression over there, 1/3 multiplied by 7 minus 4 power n. R equals to 1 to n. You can factor out 1/3, then you get a summation of 7 minus 4 power n. R equals 1 to n. This 1/3 is being multiplied by this summation, so there's actually an invisible pair of brackets here. I'm just going to draw in that pair of brackets now. Then in the next line, still within that pair of pink color brackets, this summation of two terms here, 7 minus 4 power n, the minus helps you to separate two terms, can now be split up into two summations. So sum of 7, sum of 4 power n, with a minus in between, r equal 1 to n, r equals 1 to n. 1/3 again got invisible square brackets, summation of a constant 7 that's not related to r. It just means you have to take 7 plus 7 plus 7, how many times? R equal to 1, R equal to 2, R equal to 3 until R equals to n. So n times. So 7 copies of n being added together. The shortcut to write this is 7 times n. Okay, minus away summation of, this is a geometric series, right? 4 power 1 plus 4 power 2 plus dot, dot, dot until 4 power n. Formula for Sn will be first term multiply 1 minus r power n or divide by 1 minus r. First term is 4. 1 minus common ratio is times 4. Times 4. So 4, then to the power of n. How many terms? Power 1, power 2, power n. There's 1, 2, 3, 4 all the way to n. Or in other words, you take upper minus lower plus 1. Upper limit is n. Lower limit is 1. Upper minus lower plus 1. So that's just n. Power n. Power number of terms. Divide by 1 minus the common ratio 4. Simplify, what do you get? 4 divided by negative 3, negative 4/3, multiplied by 1 minus 4 power n. Then you can just sub in. So take note, there's already a minus sign here. Then this guy goes in. So you have double negative. You need a pair of brackets. Of course, double negative will cancel off. You become a positive. Which means that you can, let me read the question again. Okay, you can simplify a bit more. Simplify a bit more, I guess. There's no need to simplify, but I guess I can multiply the 1/3 inside. So 7 over 3n, add on 4 over 3 times 3 is 9, times 1 minus 4 power n. Okay. Okay, next question 11b. So this is totally unrelated to part A. So Sn they give there's a sequence U1, U2, U3, so on and so forth all the way to infinity. And the summation of the terms, so summation of UR from R equal to 1 to n, they gave us a formula. They call this Sn and they gave us a formula for it. It's 1 minus 1 over bracket n plus 1 bracket factorial. Now part 1, you want to give a reason why the series sum UR converges and write down the value of the sum to infinity. So this guy converges. So basically it means they use sum UR to confuse you. Basically they're just telling you that the limit, okay, sum UR is actually telling you R equals to 1 to infinity, which is really just S infinity, which is really just limit as Sn, limit of Sn as n goes towards infinity. So this sum UR is actually the same as this sum UR from R equals to 1 to infinity. Then you can now replace the Sn with 1 minus 1 over bracket n plus 1 factorial. Then you must take the limit. So how do you take the limit of this guy? First, 1 does not involve n, so you can leave it alone. It's not affected as n goes bigger and bigger. N towards n arrow infinity means n is getting bigger and bigger. N is equal to 10, equals to 100, equals to 1000, equals to 10,000. You check the value of the resulting expression as n gets bigger and bigger. So 1 doesn't get affected, so 1 leave alone, minus away. Limit of this guy, n here gets bigger and bigger. So it's really just saying 1 over 10 plus 1, 11 infinity. Or the next one will be, if you get even bigger, let's say 100, for example, 101, then plus 1 becomes 101, so 101 factorial. Factorial. Then if n gets even bigger to, let's say, 1000, then you get 1000 plus 1 and factorial, and a factorial at the back. So if you check with a calculator, you realize that 1001 factorial is too big for the calculator to handle. It's actually a very, very big number. So 1, which is very small, divided by a very big, both are positive, means that you'll get a positive 0. Sorry, I mean just 0, just 0. But slightly above, always slightly above 0, but eventually goes to 0. So this is just 0. That means you get a 1. Okay, so let's read the question. Give a reason why the series converges and write down the value of the sum to infinity. Okay, you can just give them the sum to infinity and say that as n tends towards infinity, instead of basically you need to explain this key step where you go to where this fraction goes to 0. The 1 over m plus 1 bracket factorial approaches 0, which means that 1 minus 1 over m plus 1 bracket factorial approaches 0 plus 1, 1. But this is actually equals to S infinity, or what, using their notation, sum of UR approaches infinity, approaches 1. And yeah, that's the explanation already. Okay, good. Then part 2, find a formula for UN in simplified terms. So they already gave you Sn. How do you link it to UN? Again, it's the same formula. UN equals Sn minus 1. So we're going to use this formula. So let's figure out what's Sn minus 1 since we're already here. Sn minus 1 equals to 1 minus 1 over, replace the n with n minus 1. Add on 1, you get just n factorial. Okay, good. So that means that we just need to use this formula, sub in Sn minus 1. Okay, so let's do that. So Sn is what? Sn is this expression, 1 minus 1 over n plus 1 bracket factorial, minus away Sn minus 1, which is 1 minus 1 over n factorial. Open up the brackets. Distribute the minus sign. You get minus 1 plus 1 over n factorial. 1 minus 1 cancel off. You're left with 1 over n factorial minus away 1 over n plus 1 bracket factorial. What was the question again? Find a formula for UN in simplified form. I guess this is quite simple already, but if you really want to simplify a bit more, you can interpret this n plus 1 factorial as n plus 1 multiplied by n factorial. So you can combine into a single fraction. N plus 1 times n factorial. How do you go from n factorial to n plus 1 times n factorial? Just times n plus 1 top and bottom. So 1 times n plus 1, n factorial times n plus 1. Subtract away the second fraction, just copy and paste. N plus 1 times n factorial. When you subtract fractions, you want to make them the denominator the same. So these two are already the same. So you get n plus 1 minus 1 over n plus 1 times n factorial, which is actually just n plus 1 factorial. 1 minus 1 cancel off, so you're left with n over n plus 1 factorial. That could work as well. Let me just present it nicely. Okay, good. Then, yeah, done. Next. Okay, this is question 12. Proof by MI mathematical induction that this formula, this summation equals to this. Again, it is no longer in the syllabus, so we ignore it. We will have to use this formula later. Just treat this as a given. Now, part 2, it is given that FR equals to 2R cubed plus 3R squared plus R plus 24. Show that FR minus 1 equals to AR squared for a constant A to be determined. Hence, find a formula for summation R squared fully factorizing your answer. So for part 2, we have FR equals to the following. Then you want to show that FR minus 1 equals to AR squared. So I think it's easier to work from the left-hand side. So let's just do that. FR is nothing but the same expression, but FR minus 1 means you're going to replace everywhere that you see with a R with a R minus 1. So bracket 2 times R minus 1 power 3 plus 3 times R minus 1 power 2 plus R minus 1 plus 24. Okay, good. Simplify. So distribute the minus sign, we end up with minus, minus, and minus. We need to simplify down to AR squared. Okay, so for some A. So let's just see how we can do this. Can't really simplify anything in the first 4 terms, so the rest you have to multiply out and expand. So R minus 1 bracket power 3 is really just R cubed. Okay, maybe I'll just use the formula. 3 choose 0 times R power 3 times -1 power 0 plus 3 choose 1 times R power 2 times -1 power 1 plus 3 choose 2 times R power 1 times -1 power 2. Just make sure that you have a countdown 3, 2, 1, and then last one is 0. 3 choose 3, R power 0, -1 power 3. And then there's a count up 0, 1, 2, 3. I'm going to simplify this straight away. This becomes 1, 3, 3, 1R. 1R cubed, 3R squared, 3R, and a 1. Then the R power 0 just becomes a 1, so we can throw that away. Then take note that because of the -1 there will be alternating signs. Here is a power 0, so it's just 1, so it's positive. Here it's -1 power 1, so odd power, so it's a negative here. Then followed by positive, followed by negative. Okay, so I'm going to simplify it straight away. And this is gone. I am not going to write that down. I'm just going to write down the simplified version straight away. R cubed minus 3R squared plus 3R minus away 1. Close the bracket. Then minus away 3 times of R minus 1 squared. So R squared minus 2R plus 1. Then minus away R minus 1. This one maybe can expand. So minus R plus 1. And then minus 24. Okay, then we can continue expanding it. So everything copy down again. So you should really try to remember your binomial expansion so you can save some time. Then minus, or you can just use the formula but learn how to use it fast. Use the MF26 for binomial expansion, but learn how to do it fast. So then after that, -2 bring in, you get -2R cubed, positive 6R squared, minus 2 times positive 3, minus 6R, -2 times -1, positive 2, then minus 3 times in minus 3R squared, plus 6R, then minus 3 times positive 1, minus 3. Oh, then yeah. Hope I got everything right. Yeah, okay, then we can continue simplifying. Let's see if there's anything to cancel. 2R cubed minus 2R cubed. Cancel. 3r squared, 6r squared, minus 3r squared. Left with 6r squared. The 3r squared cancels. R minus 6r plus 6r minus r. Plus r minus r cancel. Minus 6r plus 6r cancel. Anything else? 24 plus 2 minus 3 plus 1 minus 24. Plus 24 minus 24 cancel. Then you are left with, what are you left with actually? Let me see. Plus 2 minus 3 plus 1. They also cancel each other off, coincidentally. You're just left with this guy here, 6r squared. 6r squared. So the answer for the question ar squared is a equals to 6, where a equals to 6. Okay, that's for part 2. Moving on, wait, we're not done with part 2. Hence, find a formula for sum r squared fully factorizing your answer. Okay, we can do that. So we start off with what is it? Oh, okay. This one requires a little bit of trickery. So why did they give us fr minus 1? Why is there a minus? Why is there a sequence and series question with a minus sign? It's because of MOD. It's in the syllabus, method of difference. Every time you see a minus, just tag on a summation. R equals 1 to n. It's a trick. R here, then summation R from 1 to n. Then you just sub in I equal 1, I equal 2, I equal 3, I equals n minus 2, I equals n minus 1, I equals n. Everything else in the middle will cancel off. You're left with a top cheese and a bottom cheese, so on and so forth. So this one is a trick you must remember. You must automatically do it yourself. Sum from R equal 1 to n. Likewise, on the right-hand side, if you sum from R equals 1 to n, on the left, you have to do it on the right-hand side as well. But this middle guy, fr minus 1, we already have an expression, which is the 6r squared here. So we'll just copy and paste it. 6r squared. Then you take the summation. So what is this? 6 can factor out. Summation of r squared, I equal to 1 to n. Here we are trying to derive a formula for this guy. So it would be smart to make this guy the subject. So that's what we're going to do. We're going to take the sum r squared as a subject, but that means I have to divide by 6. So I'll get 1/6 of the left-hand side. Okay, I just swap the left and right. Hope it's not too confusing. Just bring the 6 over. So divide by 6. 1/6 introduce there. 6 no more. But this guy and that guy, I swap around. So get this and that. Okay, good. So, sorry, let me just, oh no, what happened? Okay, so now we have this guy. We have a formula for summation r squared, but we need to simplify this down. How do we do that? We just have to do method of difference. Sub in. So open square bracket, close square bracket. Then fill in the blank. F1 minus F0, F2 minus F1, F3 minus F2, plus. That's for the first 3 terms. Then you add on Fn minus 2 minus Fn minus 3 plus Fn minus 1 minus Fn minus 2 plus Fn minus Fn minus 1. Anything to cancel? Yes. Oh, my square bracket. Let me just put it down there neatly. Then this and this and this and this and this and this cancel off. You're left with the top half and the bottom half. 2 terms. Sometimes can be more terms, especially when it involves three terms in the expression, but usually just 2. Not always. You'll end up with Fn minus F0. But wait, what's Fn? What's F0? We already have an expression for F. Right over here, Fr equals to 2r cubed plus 3r squared plus r plus 24. So that means I can just replace my r with n, r with 0. Sub in, what do you get? Fn to be this guy, replace all the r with n, then you have to subtract away F0, sub r with 0. So you get 0 plus 0 plus 0 plus 24, but make sure you have a pair of brackets after a minus sign. Just like how when you have the formula a power n divided by a power n equals a power n minus n, you must know that there's always an invisible pair of bracket after the n. Quick example, let's say 2 power 3 over 2 power 1 minus x. It is not 2 power 3 minus 1 minus x. That's wrong. You need to put an extra pair of brackets around the 1 minus x, then you distribute. Always have an invisible pair of brackets after the minus sign. Likewise, over here, minus as an invisible pair of brackets, invisible pair of brackets. Then you have to distribute the minus. Of course, the 0 you can just ignore, huh? Minus 24, not plus 24, okay? So 16 multiplied by copy paste, then minus 24. Cancel off. Whoop, whoop. Then you are left with 16 times this times the summation of these three. Can factor out a n, so you get n over 6 multiplied by 2n squared plus 3n plus 1. Then you can also factorize this a little bit, and you will get, let me just double check, I can't remember. 2, 3, 1, you get n plus 1 times 2n plus 1. Yeah, that's right. Okay, that's the formula. And finally, we have part 3. This is requesting for the formula for sum of FR from I equals to 1 to n. Now, this one, let's just sub in the FR where we get sum from I equals to 1 to n of 2r cubed plus 3r squared plus r plus 24. So now you can split it up term by term. So you get 2 times summation of r cubed from I equal to 1 to n plus 3 times summation of r squared from I equals to 1 to n plus summation of r from I equals 1 to n plus the summation of 24 from I equals to 1 to n. Now, this part is challenging. These two parts are okay. These three parts are okay. So let's just deal with the last three terms first. For the last term, sum from I equal to 1 to 24 is actually just 24 times n. Then this sum of r equals to 1 to n of r means 1 plus 2 plus 3 plus 4 plus n minus 1 plus dot dot plus n minus 1 plus n, which is an arithmetic series. So it's just number of terms n, right? Upper minus lower plus 1, n minus 1 plus 1 gives you total number of terms n, divide by 2, multiplied by first term, which is 1, last term, which is n. Then add on 3 times of summation of r squared, 3 times of summation of r squared. We already have a formula of summation of r squared from the previous working. Part 2, it's this guy, n over 6 times n plus 1 times 2n plus 1. So we're just going to copy and paste it here. Okay, now is the challenging part. You have 2 times summation of r cubed from r equals to 1 to n. How? Where do we get a formula for sum of r cubed? Here was a formula that was given to us already. Can you see a r cubed? Yes, if you multiply the r in. So let's just do it. Let's just modify this and deduce what is the sum of r cubed formula. So over here, okay, I'll just call this equation 1, then we'll come back to equation 1 later. What we have is summation of r times 2r squared plus 1, which is really just 2r cubed plus r. Oh, this is just equals to 2r cubed plus r, which is really just 2 times summation of r cubed from r equal to 1 to n plus summation of r from r equals to 1 to n. But take a look, okay, 2 summation r cubed, 2 summation r cubed, that's exactly what we want. So all we need to do is to make this guy the subject that I'm highlighting here, throw this over to the other side. So that's what we're going to do. Let me just copy down the formula that was given, half times n plus 1 times n squared plus n plus 1. Then you just need to make 2 summation r cubed from r equal to 1 to n the subject. You get formula on the right-hand side, but you have to subtract away summation of r from r equal to 1 to n, which is equal to, copy and paste, but then the summation must, on the right-hand side, this guy on the right-hand side must change into, it's an arithmetic series. So total number of terms n, upper minus lower plus 1 gives you the n, divide by 2, multiplied by first term 1 plus last term n. So yeah, that's your formula. Did they request for us to simplify? You should not simplify your answer. Okay, then I'm not going to simplify. I'm just going to leave it as it is. So from here, I can call this equation 2, and then I will say sub 2 into what? Sub 2 into 1, which means what's on my left-hand side? Remember, this equation came from here, the top guy, summation FR, the top guy is what I want. And we have simplified it down to this guy. So when you are presenting your working, always show me the top left hand, which is this guy summation FR R equals to 1 to n. Don't just sub in. Don't do that. Give me a top left hand corner expression first. Equals to what? Equals to whatever we found out from equation. That's equation 1. Oh. But now we have to sub in this guy with equation 2. So just copy and paste plus the remaining part. Just put it at the side like that. Yeah. And there you go. That's your answer already. Don't need to simplify. Answer.